The Earth is very flat.
What's up, everybody? It is Monday, April 5th, 2021. This is Brandon, host of Brandon Show. Hope everybody had a fantastic weekend and a good Easter. Happy to be back. Been a nice long weekend for me, and it is just beautiful here. So supposed to get up to 80 this week. Really looking forward to it. Had some nice time with the family. Mother-in-law cooked dinner. It's all right. And just hung out. What do we got going on today? I want to talk about the inverse square law and a couple things I've been thinking about in regards to that and Earth curvature. And we'll see what the panel knows about the inverse square law, and hopefully they can answer my questions. But before we get into that, let's see who we have in chat. We've got almost unbelievable. What's up, Ranty? Bill G, thanks for the sound check, Bill. William Evans, Ian Adams, Page 42, Salt Cedar, Brandon Cook, F. Evangelist, Dan Morris, Chrissy Heavey, and hopefully I don't skip anybody, Anthony Burrows, Matrix Media, Frank, and Enigma. What's up, guys? Hope everybody's doing good out there. And we have a few people in the panel, or in the Discord, it looks like. Let me see what's going on in there. Oh yeah, we got a nice little crowd so far. Let's go and see what's going on. First, let me give you the link to the, what is it called? Streamlabs, if I can find the dang thing here. Looks like I'm not prepared here, so okay. All right, if you want to use this, it cuts Google out of the middle. That's much appreciated. Here you go. And if you want to join the Discord, the link is in the description for the show. If that link doesn't work, just hit me up on the chat and I'll pop you a fresh invite. You can come on in and join us. All right, let's get going.
Or sphere. If you're doing it on a flat Earth, you can simply, like Curve said, if you know it's 44 miles between each.
For that observer at the subsolar point.
No, the subsolar point will only happen once, depending on where you are in between the tropics. It could happen twice a year. It might only happen once a year if you're right on the edge.
Well, I'm not referring particularly to the subsolar point. I'm talking about solar noon, the time of day when the sun is going to be directly 90 degrees above your head. That only happens once a day.
That only happens in between the tropics.
I thought it happens at the subsolar points as well.
You maybe I don't know.
What's up, guys?
What up?
How's everybody doing?
Hey, dude.
Hey, what's going on?
Is this live right now?
We're live, yeah. What's going on?
Okay.
We got Ali B, Autissimo, Jeremy, Illegal, Matrix Media J, Rob, Keen, SE Montreal, and Space Pope. Sounds like you guys were talking about that subsolar point thing that Kosho brought us on Friday. Yeah? No? Yeah?
Yeah, go ahead, Jeremy. Tell them what's up.
What's up,
Yeah,
Jeremy?
I mean, I haven't heard anything good yet. You know, these circles got me worried.
Have we gotten?
Do you mind if I?
Have we gotten any actual observations?
No.
Clocking the speed of the sun in different locations?
No, we don't have any actual. I'm collecting everyone's latitude. If anyone's in between the tropics, DM me your latitude and your country, please. And we're keeping a list. Me and Brandon got a list going of latitudes.
Do you mind if we go over the argument again, just to get everybody up to speed? I'm sure everyone knows what we're talking about, but it helps just to recap.
Well, you want to present?
Here's the thing. Here's the thing, real quick. If the Earth is flat and the sun's circling above us, then it goes from tropic to equator to tropic. No matter where you put the landmass, one of those circles has to always be going faster than the other one. The outer one's always got to be going faster. So where the land masses are, it doesn't really matter. Also, with the sky, how the sky works, or what the sun is, if it's a hologram, it doesn't fucking matter. It's there at your 90 degrees. What I'm trying to collect data for the speed of the sun throughout all both in the north and the south.
Right. Yeah, I don't have those pictures handy that Kosho had the other day.
I just I'm gonna DM you some pictures. I DM'd you one right now. I don't know if you can see it or not. Do you mind putting that up on screen for a sec?
Hold on.
I've also got Kosho's images. I'm gonna
Okay.
DM those to you as well. Yeah.
It's a really shitty image, but go ahead.
Right.
No,
But yeah, the point is that on the globe model, those concentric circles or latitude lines vary in size, with the equator being the largest one, and the two at the tropics of Capricorn and Cancer being the smaller ones. So we know that at different points, different times of the year, the sun is going to be at those two different tropics during the subsolar points. And because of the size of the latitude lines, the sun slows down depending on which latitude it's over. But on the AE map, the latitude lines are concentric circles that get larger the further out you move towards the south. So if the sun is on the Tropic of Capricorn.
Hold on, Babs, real quick. I just want to point out, it doesn't matter where you put the land. You could put the land masses anywhere. It doesn't fucking matter.
Where you put them, yeah.
All right.
Because, yeah, if the sun is circling around us, if the sun is at the Tropic of Capricorn on the Gleason's map or the AE map, that would be the largest latitude. So it would have to speed up, because we know that speed is time over distance. And we have the data. We have these distances over land. So if we can calculate the amount of time the sun takes to traverse over those distances, we can know what the speed is. And it would have to be moving faster on that specific model. So I can't see how that would work. It makes sense on the heliocentric model. That doesn't make it reality, but it makes a lot more sense than what we currently have right now.
Yeah, that makes
Depending
sense.
on what the speeds are.
Yeah, well, depending on what the speeds are. This is what I've asked for since this has been presented to me, because I think they brought this up to me a couple times, is do we have some actual observations of this happening? And when I looked at it, it was like, okay, so I looked along the Tropic of Capricorn, and it was so fast across there that it was pretty hard to convince myself that those were good times. You know,
you mind describing the nature of these observations?
Yeah, like I would say somebody standing at a location, say along the Tropic of Capricorn, with say a telescope or some way of determining when the sun is at the subsolar point, or maybe I guess anywhere between the equator and the Tropic of Capricorn, preferably closer to the Tropic of Capricorn. And clocking the speed, and then someone at another location, you know, marking down when the sun is at the subsolar point, and they'd be along the
And
same.
how are they measuring that speed?
Well, that's what we were talking about the other day. I was thinking that you could just point a telescope straight. Measuring the speed. Yeah, you'd have to just communicate between the two, I guess. Use UTC
two people on the same latitude line, and voice communication with stopwatches on their phone, or a handheld stopwatch, whatever. The first person where the subsolar point goes over them, they say, okay, go. They both start their stopwatches. The second person says, okay, the subsolar point's at me. They stop the stopwatches, and they know the time. We know the land distance. We'll have the speed.
Right.
We could do that, but I feel like there's a more accurate way of doing it, because we know that the calculation for time is, for speed, is distance over time. So we have the data for the known distances at those locations, and generally we can measure the amount of daylight we have per day, which varies depending on your location. So if you know the amount of daylight we have, can't we use that as opposed to observers looking at the sky and trying to, determine how fast it's moving that way?
Well, how would we do that? Because this is all about how fast it's going over between two known points, right? So, but
The only way to
what your
do this
method
that
would
is
be.
gonna. Sorry, the only way to do this to make everyone happy is gonna have to have two people, known locations, known distances, with the stopwatches, like that. I would have them video it too.
Well,
We're using sticks and shadows.
Yeah, I mean, how are you
to tell where
doing it, Space Pope? I mean, what was your method?
Sorry, I got distracted for a sec. Yeah, my method was to use the speed calculation, distance over time.
No shit.
Because, right. Yeah, I know. I keep repeating myself. If we had the amount of time the sun is in the sky, let's say 8 hours, right? And we know the distance where the sun is traversing, then that's our data. That's all we need. We have distance and time.
Right, but you said something about recording how much daylight was in one spot or something. You don't think my method would work, or?
Well, I'm not too sure what your method was, because you mentioned something about pointing telescopes in the sky with two observers, but you didn't go into specifics of how you'd measure the speed or how you'd calculate it.
Dude, calculating the speed is the easy part.
Finding your 90 degrees. When are you exactly 90 degrees from the sun is the hard part.
Yeah,
I was going to use sticks and shadows.
We all know how to calculate speed. It's a matter
And
of
isn't that what
getting
we're
two
looking for, the speed?
Yeah. It's a matter of getting two observations of the sun at the subsolar point along the same
How do you tell
latitude.
when you're at the subsolar point? I was going to use sticks and shadows. Brandon thinks telescopes looking at the sky.
Or
What do you
like
think, Babs?
or a tube. You know, I mean, some way of determining when the sun is directly overhead. That it shouldn't be that hard. Just point something up at the sky, and like a telescope, you'll see the light come through. And it'll be directly under. You could even really use a stick.
Sticks and shadows, really?
Well, you could, just to determine that the sun's directly overhead. Yeah.
No, I know. That's the irony of this.
Not to determine the shape, but just to determine that the sun is directly overhead.
Yeah.
But I don't know how else you would do it.
You guys,
I
I
don't
think those points only exist at equatorial positions as well, so it's not the most useful thing for talking about the other circles.
What do you mean, Don?
I mean, you're going to be talking about solar noon if you're at a different latitude. Subsolar point only happens at the equator.
Huh?
No, it happens everywhere between the tropics. All nonstop, all year round.
Yeah,
someone's
you're right.
at the subsolar point.
Yes. Yes, as it moves on that path, it's only going to be on one of those paths though at any point during the year.
Yes.
Right.
Yeah.
Right now, someone's at the I mean, I'm not saying somebody's there, but there's a place on Earth you could go to and be at the subsolar point right now.
Yeah.
Sure.
6 hours from now, 2 days from now, 3 years
But
from
what
now.
did the globe use? They use things like the Antarctic boat race a lot to talk about that 60th parallel region and stuff like that. I don't know if the tropic goes down that far. I don't know where the zones are, I'm be honest. I just know that you can't do it everywhere at once.
Yeah. Oh, where's the tropic at again? Is it 45?
It's like
23
23
that's
degrees
right.
or something.
That's right. Yeah, you're right.
20 point something, 23 point something. I don't know.
Yeah, you're right. It's the tilt, right?
But you can use solar noon either way, I think, right?
Yeah.
No, we're not using solar noon.
Well,
Nope, subsolar points.
it's subsolar point. Yeah, it will be solar noon also.
Yeah, Kosho was trying to
Well,
talk. I don't know if you were listening.
There's
James.
something I'm still confused about with the subsolar point. They say that it's when the sun is directly at a 90-degree angle with the surface of Earth, but we know that over the course of the day, the sun is not always going to be at a zenith angle. So how are we gauging what the subsolar point is when how do we do that if you know what I mean?
The goal is, Mr. Babs, you have two observers, and so you have two people at positions where you predict the subsolar point is supposed to be. Let's say tomorrow, they're at the same latitude tomorrow, and each of them just confirms the moment they're at the subsolar point, and you can do that by making sure there's no shadows cast by anything, by a building, by a stick, by anything. There's no shadows. On the sides of anything.
So is a subsolar point at a specific time of day, like solar noon?
Solar noon is the same for everyone along the same longitude, but it's at one specific latitude. So if you're at the point where the sun isn't traveling over that day, then at y'all's longitude, local solar noon, you'll be at the subsolar point because it's going to be directly above you.
Right, and this is exactly what I was telling you, Jeremy, that the subsolar point only happens at a specific time of day, solar noon. So if you have two observers, I'm just trying to understand what your methodology was when you said you're going to measure it using two observers at solar noon.
You have two observers on the same latitude. The subsolar point goes by the first guy. He's in voice communication with the second guy. He says, yo, start your stopwatch. They both start it because it's subsolar point for the first guy. The shit goes around to the second guy. He goes, okay, it's here, subsolar point. They both click their stopwatches, and now they both know the time. They know the distance and they know the time.
It would have to be a relatively significant distance, though, don't you think?
I mean, yeah, I would like to use a lot of distances all over the place.
Yeah,
Because if we're talking about solar noon, at two separate locations, they have to be relatively far away from each other.
Sure, yes. At least separate cities, at least. I mean, you know, the more points you have, the better. I doubt the speed of the sun is changing throughout the course of a day. It's possible. That's why I'd like to get points from all over the map. So,
is solar noon at different times? Let's say we're working with one latitude. Would solar noon be at different times on different locations on that latitude line?
Yeah.
Okay.
Exactly. Yeah.
That's a valid point. Yeah, my bad.
Exactly the way I described it. The way the sun moves across the Earth, it moves along the subsolar point, but it also the longitude or its meridian will follow all the way around the Earth. So if you're on the same longitude line as where the subsolar point is, it'll be the local solar noon at that location.
Right. And I offered a method of how we could measure the speed, but they said that it wasn't valid.
But what did you say?
Which was if we have known distances and we know the amount of time that daylight is going to last at a specific location, all we need to do is get the distance we're working with and the amount of daylight we have, and we have the speed. We can calculate the speed just based on that.
The reason why it doesn't matter how long the distances is because the time you already know. Like you already know that its entire loop is going to happen once in 24 hours. And so all you have to do is measure its distance that it traveled in whatever two locations you've observed, and then divide it by the time you did that in, whatever it was, and then just multiply that out to the 24 hours, and multiply it by 24, and that'll give you.
So like segmented ratios or whatever, Coach, just a ratio, just segments, basically.
Yeah, well, you can take any two segments. Same way if somebody was running around a track, and you didn't know, but they were always going at constant speed, but you didn't know, wherever they were on the track. As long as you knew the time it takes them to go all the way around, and you knew the time it took them to get from one interval to another interval, then you can get their speed the whole time.
Average speed's pretty consistent. I mean, but this is just longitude, though, right?
No, this is latitude lines we're working with here. And closer to the north, the latitude lines are smaller, and they get larger as you move towards the south. So if the sun is traversing across those latitude lines over a 24-hour period, that would mean closer to the south, it would need to be moving faster because it's covering a larger distance. So that negates the Gleason's map and the AE map.
It's more than that. No matter how you put the land down on the flat plane, it doesn't matter where you put the land. This one of the circles, it cannot go from lower to higher to lower, from tropic to tropic. You know what I mean? It can't be slower, higher, slower. And no matter how you put the land masses or anything, it doesn't matter what the sun is. Don't come in here talking about the sun's a holographic mirage of the luminiferous. It don't fucking matter.
Yeah, all that matters is what the sun is doing.
Yeah.
Yeah, it doesn't matter what the sun is. All that matters is what the sun is doing.
So
it would have to be moving faster.
do you understand now, Space Boat?
I always understood.
Well, what the fuck are you asking so
I
many
always
questions
understood
for?
this point. No, I was asking you how you plan on measuring the speed of the sun.
With the walk, you know, two guys in voice contact. We'll hit the stopwatches. They'll know. We get the sticks and the shadows, bro. Some Eratosthenes shit. Not really, but
Right, and that makes a lot more sense now that I understand that you can have solar noon at different locations on a single latitude line. I didn't know that before. That's why I was
it's
asking.
always at different locations. It's never at the same. It's always.
Yeah, it moves across the latitude line, so it's only going to be in a single latitude, line at a time.
All right.
Right. But let's say we're both in Mexico, right? We're both on the same latitude line. So our solar noon is going to be at a specific time unless we're a significant distance away from each other. That's the point that I was making.
Yeah.
So yeah, how big of an area and it's like square mile? Is it like a 60-mile area that would all have no shadow?
So you'd want to think about it like in degrees. And so if you imagine that, let's say they all had to be within a half a degree of each other. If they all have to be within half a degree of each other, then you want it to be half of the 69 miles at the equator, which is 35 miles. So you'd want it to be within a 35-mile, east to west distance from one another.
No, that ain't enough. 35 miles. Fuck that.
That'll give you less than half a degree of error. If there's, unless you need it to be tighter than that. But you want it to be longer.
Yeah, we need people like.
No, this is just for the point. This is just for Halloween noon. This is just the point where there's no shadow on the object. It's not. He's not talking about measuring the segment by this. This is just how big of an area it has. Right, Kosho? Is the
Right, that's what you're asking.
All right.
Yeah. What's the time frame into where there's no shadow? Like, does that happen for 3 seconds, or is that like a 30-minute process where there's not going to be a shadow?
Well, it moves about a degree every 4 minutes. So, yeah, if it moves a degree every 4 minutes, then by the time it's happening to you, 4 minutes from then, it's already going to be 1 degree difference. So,
yeah.
So this is all going to happen within a 4-minute period.
This at the equator, and everywhere else it's.
No, I'm saying pretend we got the stick
ground,
and we're waiting for the sun to come over, right? All of a sudden, I'm going to say, okay, there's no shadow. How long does that last for until I can say, okay, there's a shadow on the
4 minutes is 1 degree. So, yeah, 4 minutes. After 4 minutes, if it was local solar noon for you, it's definitely not going to be local solar noon anymore.
So this is all going to happen within a 4-minute window, basically.
At each location, yeah. But
yeah.
Time has that time. It has the time that it's going to be, so you can be ready,
Yeah, we'll get set up a couple minutes early, yeah.
So anyway, what we need is a known distance along the latitude line, or the sun's path, from between two locations in the south. And we need 2 measurements of the sun at the subsolar point. And that should give us the data, right?
Or you could do a third to make sure that the pace is consistent.
We're going to want to do this on as many locations as possible. All over the place in the north and in the south. So everyone,
I think the north matters as much as the south does.
Yeah. Well, it would be good. It would be good to have it along 2 latitude lines, because then we'd have those to compare the speed along those 2 latitude lines.
Yeah,
I'm trying to get these speeds at a whole bunch of points. We want one in the north, the equator, and the south.
Yeah, but the north and the equator could match on both models, right? It's the south.
Yeah, but
we still need that data,
it's
though.
only the south that's in contradiction.
Well, no. We still need that data, though.
Yeah, the more data, the better, man. But I agree with you what you guys are saying. That definitely the south is paramount. But the more data, it's not going to hurt.
Yeah, we need the north. Listen, these circles. It has to be going faster. Say the land's not right, and it's a different way than the AE map or whatever map you're thinking of in your head. We just need the data for all the 3 main circles. You know what I mean?
Right. Yeah.
That way, one of the circles.
Yeah.
One of the circles, no matter where the land is, It won't matter if we get all 3 points, both the tropics and the equator. It won't matter where the land is on the map. One of the circles has to be faster.
Yeah.
So
Yeah.
anyone who's in between the tropics, please DM me your latitude and what country you're in. Thank you.
Huh.
Me and Brandon have a list. We got a list going. It's pinned in our DMs.
It's gonna have to be planned too.
Yeah.
You need 2 people along the same latitude line. So you'll have to probably get one person to go to the latitude line of another person.
Yeah, an hour or a half-hour drive or something, maybe, to get close. Yeah.
Yeah. And now how do you validate the actual distance between those two? Because I know we have like Google Earth and whatnot, but that goes by roads. And I know we have
No,
Roads is not the worst thing.
no, it doesn't go by roads. No.
You could use roads though. That isn't.
No,
the-
you would not use roads, and you don't want to use roads, and you don't have to, because you can just pick 2 points, and it tells you the distance between them as a crow flies.
verify that. So you'd have to get somebody to drive between the cities to verify it. In which
Yeah.
case,
yeah.
If you wanted to verify it, you would be limited by using roads. And in that case, you would probably check it to see what it is as a crow flies, and then drive it and make sure that it makes sense, like it's like around the same range. But if you trust the maps, then that should be sufficient. But if you don't, then
No, because it would be based on your model in one case, and it would be based on our model in another case.
I mean,
If
most
we
of
were to
these land
assume the
distances.
because the only distances we know, we don't have distances by the crow fly actually measured. We just have it by the roads, right?
Yeah, I
If
thought-
we do it in Australia,
No,
if
map-
we do it in Australia, you know, those distances are pretty close. Like it might be off a little bit, but I mean, people are traveling those in cars. So yeah, you're going up hills and down hills a little bit, but for the most part, you're going to get a pretty accurate number.
How far off does it need to be though? What is the
Yeah, it's a good
margin of
question.
error? That's all I'm
It's a
concerned
good
about.
question. Could it be off 20 miles? Are you still going to get an accurate number?
Right.
the 2 different speeds. The 2 different speeds are 950 for the globe at the southern tropic, 952 for the globe, and 1308 for the flat Earth. So that's a pretty big difference.
It's not different.
So yeah, you should be able. I'll try to see what distances that would be. Hold on.
Yeah, we
You
should.
want to be percent, and you trust Dave. You're in 50% is dangerous.
Yeah.
No,
that should
Brandon's
be good.
asking how
Yeah.
we trust the distances, these known distances.
Jeremy, look for target areas. Look for plateauish type places in South America or Australia or Africa. That they're plateauish. They have a straight highway somewhere. Same type of sea
Yeah.
level elevation. Just find some target areas.
Yeah.
I mean, places with major roads in between them, you know, those distances, it'd be hard for them to fudge them a lot. Like Brandon said, though, how far could you be off? Could you be 20, 30 miles off and still have an accurate speed for the
10%.
sun?
Right. Like if you're dealing with South America, how wide is South America? It's really not that wide.
Isn't GPS data accurate? It's not 100% accurate, but it's pretty accurate.
If you got answers. So let's say that you were doing it with somebody, and you guys were 10 minutes apart. Like the subsolar point was where you are, and then 10 minutes later is where they are. The difference would be they should have traveled 158 miles on the globe, 158 miles, and it should be 218 miles on flat Earth. So that's a pretty substantial. You'd have to account for 60 miles.
Yeah, we should be able to. Yeah, you're right. Yeah, we should be able to validate that. That should be fine then. Okay, cool. So Jeremy, you're working on setting this up or what?
Yeah, everybody and their mom, send me your latitudes if you're in between the tropics, please. We got a list in our DMs. It's pinned. It's in there.
It shouldn't be that hard. We know a lot of people in Australia that could probably.
We need
do it.
northern people too. It's not these tropics. You got to be in a little piece of Mexico. There's very few places. Africa. How many flat earthers we got in Africa?
There's a couple.
Like one.
You don't limit it to just flat earthers, man. Just people. You could just get people who are.
Is there any Globers? You got any Globers in Africa?
Yeah, there's a couple people. There's
No, you
2 or
don't.
3.
You just made that up.
No, there's not. There's Sam, whatever. He lives in South Africa. There's a few other people who live in there. But I'm gonna offer you one last thing. Jeremy denied it, but I think if you think about it, it's perfectly reasonable. The subsolar point works out because it is going to take 24 hours for that to make a full circle. But just like I told you, the subsolar point shares its subsolar noon, local solar noon, with everything along that same meridian, over the same longitude line. So if you were two people in anywhere in the south, anywhere at all in the south, two people in the same latitude, if they were to measure the speed that the sun travels, they'd be able to measure how fast their local solar noon is traveling from point to point. And because it takes 24 hours to go all the way around as well, you can also multiply that out to see how the speed of to see what that distance is as well. So it works.
We're only doing subsolar points.
I know. I'm just offering this to you because it's a reasonable person would allow for both, but you do however you want.
Yeah,
that's an unreasonable. That's an unreasonable request.
We don't need more assumptions. It's easy to know when the sun is directly overhead.
Yeah, it's easy to know when it's directly south of you too. The shadow's pointing directly north.
Yeah. I'd rather just do it directly overhead too.
Yeah, this overhead thing is what got me.
I mean, yeah, it'll be a little harder, but it's just...
It's not the hard part. It's you're limited to wait to the end of the year now. You're not going to be able to do that until the end of the year. Whereas you can do it from the local solar noon on any given day.
Yeah.
Hello, Mike.
I don't know. I guess you'd have to describe more how you do it from just solar noon, but
the only difference is, like I told you, to make sure that it was a subsolar point, you would just make sure that there was no shadow. But to make sure it's your local solar noon, all you have to do is make sure that the shadow your stick or whatever you're using is making is the longest that it ever is, and it's also pointed directly north if you're in the north and directly south if you're in the south.
Nah.
Hello, Mike.
Hey, what's up, Brian?
Hey, Brandon. Hey, I can only come in for 2 or 3 minutes. I'm trying to do what you're talking about, but the problem I had is everything is based on the globe. All the information you get is based on the globe. GPS may work because GPS uses Cartesian coordinates, which uses flat coordinates, but then you have the oceans to deal with. So they can say the oceans are any width.
Yeah.
That's the problem. So land masses you might work out about the same. You might be able to work out a land mass size and whatever else, and be able to somehow figure something out there. But the problem you have is the oceans in the south. What I would say about it is this, right? This is something for the globe side and flat side to think about. It is admitted that the sun moves faster across the sky in the southern summer, right? But the sun also always holds a 15-degree movement across the sky per hour. So how can it be moving faster? And this is admitted by mainstream to be moving faster in the sky in the southern summer, but still hold 15 degrees an hour. You know the answer to that.
Yeah, that's a good question. Yeah, how's that work?
It's easy. If you imagine a clock hand, imagine a clock, a very big clock, one the size of I don't know, make something 25 feet.
Imagine
length. The hands are 25 feet. You have to imagine this because it's the only way it'll make sense.
Okay.
The hands are 25 feet. Now, no matter what, the big hand on the clock, the big hand, the one that gives you the minutes, those are always moving. A full circle in 60 minutes, in 60 seconds. Always makes a full circle in 60 seconds. Okay, so its angular speed is always exactly the same, no matter where you are along that arm.
Right.
But if you're at the length of if you're at the end of the arm, it has to travel a circumference of something like 250, something like, let's call it 150 feet circumference. So it's traveling 150 feet in a minute. Whereas something in the center of that arm, something very close to the center, it's measuring like a very tiny circle in 1 minute. So their linear speed is much different. One's going much faster than the other, but their angular speed is always exactly the same.
Right.
I think
Yeah, it sounds like you're making a flat Earth argument, Kosho.
in the sky.
Get that?
Yeah, just like race cars on a racetrack. If you have race cars all moving at the same rate, The one on the outer edge is going to be moving faster than the one closer to the center,
Not on
but
a
they're all
globe.
moving at the same rate.
Not on a globe.
Brian,
But he's
say,
making
guys,
he's making a flat Earth argument.
It's not a
Yeah.
flat Earth argument.
What you just
How
said
is that-
supports
how is
a
that a
flat
flat
Earth.
Earth?
Hold on, Kosho. No, I was asking you to explain it, how it's supposed to work on your model, how it can be seen to be going faster across the southern sky in the summer, and then it is in the north, and still
It's
fit a globe model. What
You have to
the
imagine the
contradiction?
latitude lines as layers of circles above each other, smaller and smaller circles above each other. Okay, so the person on the equator is making that full equatorial path in one day. So taking that whole path in one day.
Yeah.
But depending on how far north or south you are on a sphere, those circles are getting smaller and smaller and smaller and smaller. It's the same thing as moving inward on the hand of a clock.
the
It
ground
shouldn't
speed.
go
Kosho.
faster across the southern sky during the summer.
Who said
on
that
the
it
globe.
goes faster across the southern sky on the globe? Who
That's
said
what
that?
Brian's said.
That is the official. That's the original sun cycle, and that's the official. If you look at Kepler's
No, I'm asking where the data is to substantiate that. Where is the data to substantiate that the sun moves faster in the southern hemisphere?
That's a good question.
Brian did a presentation on this once.
Well-
I heard it.
I did, yeah. Well, I got information online, official information that stated that the sun does appear to move faster across the sky. Even in the globe model, it's stated to be moving at over 2,000 miles an hour faster in the southern summer. Let's say at December 21st than it is at June 21st. So, like what Kosho said is validating what I said. Is that how can it be observed, supposedly observed anyway, and admitted to be moving faster across the sky in the southern summer and slower across the sky in the northern summer, but yet it's always making a 15-degree per hour rotation.
Yeah, exactly. That's what I was asking.
Talking about
also.
two different things, that's why. But I think Don was trying to say something. I'll correct it in a second. But go ahead, Don.
It's closer or further away from you. Like Kosho said, the difference is it's not ever going to be different on the ground speed. And that's what's throwing you off intuitively.
Well, to be honest, he's
Exactly.
talking about a completely different topic.
15-degree now.
He's talking about the orbit of the sun. We orbit around the sun. The speed difference is 2,000 miles per hour different from December to June. This is true.
Yeah, but
This has
you're
nothing to do
forgetting, you're forgetting
This is something
something,
we're talking
Kosho. But Kosho, you're forgetting something. This is a problem for your model because your globe only rotates at 15 degrees per hour. It can never show the sun moving faster across the sky. So if the sun is measured, and this is mainstream saying it's measured to be moving, and it's even in Kepler's analemma, for the sun to appear to be moving across the sky faster, then how do you explain that with just a 15-degree an hour rotation?
Yeah.
When the sun is always holding a 15-degree an hour rotation, yet it's admitted to be moving faster and slower throughout the year.
As I said, it's not the sun that's moving faster. It's the Earth that's orbiting around it faster. And
Kosho,
regardless,
is
the
it
thing that's
moving across the sky
the only
faster?
speed change, the only speed change.
Kosho, stop, because you're going down a road that doesn't make any sense in this conversation. Does
Why
the
don't you bring
sun
up
move,
2,000 miles per hour
regardless
difference?
of what causes it, in the south during the summer, the southern summer, is the sun seen to move across the sky faster? Yes or no?
No.
Okay, well, that's the fact that's in dispute now. That's what Brian says is knowledge that we have. That's admitted.
Could you post your video,
And-
Brian?
and you just
I want to
made-
take a look at
hold
your
on,
video.
Hold on, God dang it, hold on.
The
Why
video.
are- hold on. Kosho, why are you making excuses for it, telling us about the speed of the orbit and shit if it doesn't move faster?
Because that's what he was just describing. When he said that it's 2,000 miles per hour faster, he's describing the speed in which the Earth is orbiting around the sun. That is true. That's 2,000 miles per hour faster. But the speed the length of a day, it varies by something like a minute or so maximum. That's the daylight length of a day. But the actual length of a day is going to be it's not going to be anything that's going to make a significant change.
It doesn't change. I
Well,
never
exactly.
heard they change.
That's exactly what I'm saying. So the only thing that does change is the ground that the sun is right above. So that's the speed that changes. The speed changes because the ground is bigger.
Huh?
Do you understand? If you state that the length of the day changes, it means that rotation speed of the globe changes because your whole day is based on the rotation of a globe. So it doesn't work for you.
Just explain this. I really don't want to bore everyone again, but You know, you understood what I meant though before, Brennan, right?
You're
When I
talking
said
about its path as it travels around the sun, supposedly, is 2,000 miles per hour faster in the southern summer.
right.
So how do we know that? How does that manifest itself on Earth? What does that explain? What phenomenon?
Is one way that is one consequence of that. There's a few. There are differences in the day length of a day, and so there are. What's his name? Flat Earth Data was talking about this the other night, but he also was conflating a few things. The amount that it's different by is not enough to account for any kind of speed change. It's just like it's like under a minute different, like shit like that.
Okay, so Brian has made a claim that the sun moves faster in the southern hemisphere. Can we see the data that supports that?
Not my claim.
You just claimed that. You said that the sun moves faster in the southern hemisphere.
Yeah, well, I could post stuff in a while, but I can't post stuff now. I'm just on my phone. But I mean,
okay.
You can go and check this out yourself. I mean,
I'm just wondering why we're running with it when you haven't provided any citations to back it up.
Why don't you look at Kepler's analemma?
Brian did do a huge
but you're
presentation
the
on
one
this.
you're making the claim, so I would expect you to provide the data to support your claim.
Shut your crap for a minute, you'll be able to tell you, you know. I mean,
you're making a claim, so you should provide data to support your claim.
You ask for a lot of things, but then when I start telling you about them, you don't want to hear it.
No, I don't want you to tell me about it. I want you to provide a citation for it.
So all you have to do is Google it. It's there. Look at Kepler's analemma. It's stated in these analemma.
Right. So you're just going to make claims and not back them up. Right. Okay. We don't have to believe what you say. We're only going to believe citations.
You don't have to do anything. You don't have to do anything. It's up to you, lad. Whatever you decide to do.
Brian, do you know what number?
How do we know that you're not just making this up?
Brian, what?
Make things up.
Brian, what show? Hold on. What show did you present that on Oakley's? Do you remember?
No, that wasn't on Nathan's. This is what I've been trying to tell him. But
it wasn't?
It wasn't on Nathan's. It was on Ranty's old channel that he had to delete.
Oh, that's right.
That's where it was, and it's gone.
Wait a minute. What channel? Oh, Randy had to delete a channel at one point?
Yeah, he lost a bet. I don't know. I think it was to Anthony Riley. I can't remember what it was. But there was a bet lost, and that's where it was. It was the first presentation I ever did on Ranty's, and I think it was the second presentation ever on Ranty's when he first got his channel.
Damn.
I wish they would give you the opportunity to like download your videos before they deleted it all.
Yeah, they're
well. You presented this before, so I would expect you to be able to pull up the data. So yes, I don't understand why you can't do that. That's not a difficult thing to do. Okay. You know, rather than spending 10 minutes telling us about it, you could just go and get the data and bring it back, and that would substantiate your claim.
Maybe if you shut up, you seem very triggered.
No, why are you telling me to shut up, you dumbass? I'm asking you to substantiate your claim, and you're not doing that. You're just telling us about it.
I know your globe is in trouble, and you're very, very triggered.
I'm not a glober, you fucking idiot. Yeah, provide your data. Don't just tell us about it, you dumbass.
Yeah, you're an absolute glober. You're an undercover glober since the first day I listened to you.
Yeah, and you're just a liar. You're just making shit up right now. You haven't substantiated anything you're saying, so you're just a liar.
Okay. I'm going to go out and I'm going to get.
Yeah, carry on. Keep lying. Go on. Just keep lying.
I'm going to do it right now. And then we'll see, won't we?
All right, cool.
You little glober. I have no problems with globers, but I do have problems with little undercover, pretend to be flat out globers.
Weren't you going to get your data? Weren't you going to get your data?
I'm going to say something about what Brian just accused you of, because I think that's fairly offensive for a reason that I was going to compliment you guys in here, you know, Jeremy, Babs, Brendan, and all of you, because the way that there's a certain honesty to dealing with problems like this that not a lot of flat earthers seem to possess, at least sometimes when they're confronted with certain things. So it's like the fact that you're that you see an issue and realize it needs to be tackled and realize it needs to be addressed. I mean, there's a certain amount of honesty that has to come with that. So
well, I don't see an issue. I see an opportunity to answer a question.
Yeah, but
because you haven't provided anything definitive. You haven't provided us any observations. We don't have any real world data. All we have is you pointing to the model and saying, according to our model, this is true, so therefore it's true. Now, I know you think the model is based on real world data, but I don't know how to back that up. So all I'm asking for is some real world data. And if it turns out that the sun indeed goes the same speed along Capricorn and Cancer, then we can talk about that. But there hasn't been any, actual observations, no empirical data provided.
Well, now I'm going to go from complimenting you guys to defending myself now.
No, I'm not. That's not an attack on you, Kosho. I'm just
I'm just saying, because I'm just defending my claim, at least, or Jeremy's argument, because I'm not necessarily bringing you something saying, hey, this is proof, shut it down. I'm saying this is something that is a distinction between the two. In one case, this cannot be true. In the other case, this has to be true. You know what I mean? It's like one of those things where there's a distinction between each model.
No, that's awesome. Yeah, we've been looking for stuff
hold
like
on.
that. So that's awesome.
Hold on. This is not my argument. All right. This is Curved. You or Curved's argument or something. So
put names to it then.
Yeah, you still haven't been able to calculate the subsolar point. And there's also the analemma for the moon, too.
Let's go ahead and, because we need to dip this in the butt. Why is anybody involved in the analemma? Why is this happening? Why the whole point of this is that we're not worried about what's happening in the sky. We're worried about what the subsolar point means on the ground, how that position moves across the ground. So nothing about what's happening in the sky, at least looking up there, matters.
Yeah, the analemma is interesting though. And the moon analemma. Why do you bring this up, Crit? Because I saw you mention this over the weekend. And what's the relevance?
It became a big deal. Well, I guess I wasn't following the conversation well enough. I thought that it was had something to do with the analemma.
No, we're talking about the speed of the sun across the tropics and how it would be different on a flat Earth model and a globe model. At least that's our assumption.
Yeah, it's not. That's the big thing, that these observations predate all heliocentric models.
Which observations?
Like the sun moving through the sky.
Observations of what though? I mean, what did they observe?
The sun moves through the sky.
Oh, the sun moves through the sky. Yeah, that's what we see. Yeah. Right. No, I get that, but
and then it makes a pattern over the year.
Yeah. So that's interesting. But why does the moon makes the same pattern, right?
Yeah, it does. And that's interesting too, because the WS had said the only reason the sun makes that pattern is because the Earth is rotating around the sun.
Right.
So then if you apply that logic to the moon's analemma, that would also mean that cause and effect relationship. Because he had said remember I sent you a screenshot there. He said the analemma is purely the Earth's tilt and orbit around the sun. Now explain the moon analemma. And he said there doesn't exist. There is no moon analemma. Then I posted him, basically a source from NASA.gov explaining the moon's analemma. And it went off the rails at that point,
Right. Well, there's clearly a moon analemma, so I don't know why he would say that there isn't.
He just probably didn't know the model well enough. He probably heard someone told him the analemma is caused by the sun, the tropics and the tilt and the seasons. And you're like, well, now explain the moon's analemma. And he just denied it at first without actually researching the model.
Does it follow the same pattern as the sun analemma, the moon analemma?
Yes, it's not like that, Kosho. I don't look like that. It doesn't even look like that. Not the new one that NASA released.
There's not a new one that NASA releases or changes it. It's the moon itself. It's not going to look anything like the analemma that happens, and it's not even going to stay consistent because the moon has the moon has phases, first of all, right? So you're going to see it some of the times and not see it the other times. That's why there's a huge gap there, right? And it's going to have those phases at different distances at different months. So it's going to look strange, month to month. It's not going to be consistent month to month.
Yeah, but the moon has an offset elliptical orbit of the globe Earth, the same way as the globe Earth has an offset elliptical orbit of the sun. Yet they both have, supposedly, when you look for pictures of it, they both have a very similar looking analemma. They both look like eights with a big wide end and a smaller top end of it.
Those pictures I posted, did they look like eights to you?
If you follow the globalist logic, there would have to be an analemma if you're on the moon looking at the Earth. The Earth would form an analemma, not the other way around.
There would be a shape. I mean, you can make this design sort of thing with anything like that changes each day to day, and just take a picture at the same time each day. You can do that with anything. The question is, what shape does it make? And you're going to get different shapes depending on.
Anyone who searches the lunar analemma will get like a figure 8 type photograph. I don't know how true it is, but that's what they'll
Right
get.
there. Figure 8, right there.
Yeah. I posted a link in the chat. I can get other links. I'm not going to get them now. I'm going to go for a show and stuff. But that's just one link. I can get others that will state. There's even a link in that called analemma.com. You can go to that, and that tells you the same thing. It states that from our position, the sun will appear to move faster through the sky in the southern summer.
Do you know where at in here? I brought it up on the screen, which I should be sharing in Discord. Do you know where at?
I just threw it in general.
No, I got the link.
I think is that it?
I got the link.
NASA.gov.
Yeah, that's the one I linked to. It's the same one in chat that WS tried to deny.
It says in here somewhere that the sun appears to move faster in the southern summer. Is that what you're saying?
Yeah. If you go down, it'll talk about how the globe Earth is closer to the sun in the southern summer, and it moves past it faster in the southern summer. But it says, if the Earth didn't spin, it would appear that the sun is moving around us faster in the southern summer. They literally state it's just back engineering of the observations of the sun. That's all it is. We observe the sun doing something. They back engineered into an analemma using
the difference is less than a minute throughout the day.
Well, that doesn't work for your globe because your globe has rotation. You can't have a day that's a different speed, a different length on the globe.
Every day has different lengths.
Your rotation has to slow down or speed up. You understand?
Every day has different lengths, man.
Yeah, this comes from the show on the 3rd. Brian's logic presented something with the analemma in 15 degrees per hour.
Yeah, that was me. Yeah.
All right.
Okay, so it's good that you're here because then you get to explain it again. Because I guess WS just went right over his head last time because he posted a hit piece on you, like a smack talk in chat, and then decided. Then once he found out that the moon does the same thing, then decided to deny it and then go crazy.
WS is clarifying his position too, that he claims he never said. It's a misunderstanding that there was no moon analemma.
I mean that's possible, but he also says that text chat is far superior to all versions of voice, which is why he doesn't use voice.
WS, I think this is where the confusion comes from here, and then we'll move past this. Crit says the moon also has an analemma. This alone destroys your claims. So I think Crit, he was responding to this portion. He's saying this alone destroyed your claims when he said no, it doesn't, and not the moon has an analemma place.
Oh yeah, but here's his claim was the analemma is purely the Earth's tilt and its orbit around the sun.
Oh yeah, I get that part. That's a whole different
That's his
issue.
claim.
Yeah.
So I said, here is a moon's analemma.
No, dude, listen. What does each one of these moon analemmas have in common? The thing they have in common is they all look different from one another because it's not going to do the same thing that the Earth does. The Earth makes a consistent path around the sun.
It depends on where you're filming it from. Depends on your location. It depends on your location.
Well, no, yeah, it's going to be upside down, right side up, or whatever, but it's going to be the same basic shape. But these moon analemmas or whatever, they're going to be different phases on different parts of its cycle. I mean, orbit, whether it's closer or further. Whereas the Earth,
Can I just add to that, Brandon?
It tilts at the exact same place every time.
If your location is different, it's going to look a bit different because your perspective of it is different.
Oh, it's Adam.
Sorry, man.
Excuse me, Brian. Adam, you said something? How's it going?
yeah. Evening, guys. Evening, Brandon. Happy
Hey,
Easter.
Hey, Brian. Hey,
Right,
Adam.
right, bro. Just there appears to be some comparison being made here. The only point I'd want to make is that the sun's analemma is plotted over a year, as its path is measured each day at its peak, as it travels between the two tropics over a year. I think if you look at all of these moon analemmas, it's very different. The moon's path and its analemma is created over a month. So I wouldn't necessarily say the two are directly comparable. The moon is subject to its own particular eccentricities in terms of its angle of appearance in the sky. So I think the two are different, and certainly you're not even using the same baseline, because one you're plotting points over a month and the other fundamentally you're plotting over a year. So I wouldn't be comparable.
Good point.
Other than they're cyclical.
Because that's what this little thing here shows, even though it's couched in the heliocentric model, it shows by month. It gives you a different picture of the analemma by month.
Yeah, that's exactly what I just said.
I tried to look into the lunar analemma before, because I did when I was looking into the solar analemma some years ago, and I couldn't find hardly any information about it. All you can find is they say it's happening and they give you like a photograph, but to try and find out anything more than that was impossible at the time anyway. I couldn't find anything about it, and I searched every way I could and I couldn't find nothing about it.
Well, let's go back to this, Brian, because you posted this here. Is this the part that you were referring to?
1 second.
I'll read it. I'll read it so people can see it. So if you measure the sun's height above the southern horizon every day at the same time, that height changes. In summer it's high, in winter it's low, and that's why the analemma is extended in the north-south direction. Now let's look at the orbit being an ellipse. That means that sometimes in January we're a bit closer to the sun, and sometimes in July we're farther away. When the Earth is closer to the sun, it orbits faster. And when it's further, it orbits more slowly. Imagine for a second the Earth didn't spin on its axis. If that were the case, it would take the sun an entire year to go around the sky once. What? And our day would be as long as a year, but in January the sun would move across the sky a little faster, and in July it would move a little slower, reflecting the change in the Earth's speed around the sun.
Isn't that funny that corroborates exactly what I said he was claiming before? The orbit, though, has nothing to do with the fact that it's going to still take full 24 hours for it to go around once. It was giving you a hypothetical if the Earth were not rotating, that you would have those longer days in the south. But we don't move around, so.
Because on the heliocentric model, the movement of the sun is caused by Earth rotation, not the orbit around the sun.
This is a problem too, that the flat Earth conceptual idea, or the flat Earth map, does get wider as it goes further south. That's why the southern part of the analemma is larger. It's simple. It's really that easy to understand. A caveman can get it.
Yeah, I went through a lot of that stuff a couple of years ago. We can ask Ranty about it. And I even worked out, let's say, using the latitude lines, using the tropics and the equator, a speed using a flat map. Now, you couldn't guarantee any of it because the maps are just flattened off a globe map. If you flatten them using the longitude lines, you can, using degrees, create a radius. Like a lot of people on the ball side don't realize, as soon as you flatten that map, flatten that ball, that changes the dimension straight away. So, for instance, the equator wouldn't be 24,940 miles. It would be 38,800 and something miles. That's what it would be on a flat world. But the distances don't change north to south. It's only east to west the distances change. Because on the globe, you have the curve outside the globe that takes up all that extra distance. For example, Helsinki, which is in southern Finland, to Libreville, which is 40 miles or 45 miles north of the equator line, is 4,212 air miles. But that's less but sorry, that's more than the globe Earth radius. So you can see that north to south, the distances don't change. It's only east to west, especially south of the equator, that the distances will change. So you can do that, but it's not concrete because you don't know for definite the definite dimensions of the world. But as soon as you flatten the map, you can use degrees north to south to calculate a radius. I came up with the speeds of the sun at June 21st at the equinoxes and December 21st. Now, I can't prove that because the sun always moves at 15 degrees an hour.
Right.
But, you know,
You can prove that, but I got the same value, about 2,000 miles per hour, according to his.
no, because you were using an equator that was.
I was using your numbers, man.
Your equator was 24,900 miles.
No, I know mine is, but I'm used yours. I used yours to come up with the speed.
What was your equator size, Kosho?
My equation was 69 miles.
No, your equator size.
Yeah, my equator is 24,000 miles. You just said yours was 39,000 miles.
38,000 plus, yeah. It would.
Right. So I used yours to come up with this number.
Map, that's what it is. Because you see, Kosho, your equator is based off of the radius of 3959, which was actually 3963 for your equatorial radius. So your equator is based off 3963. Whereas that's only on a globe. If you flatten that map, the AE or Gleason's map, as soon as you look at them, then that changes the dimensions.
I understand that.
Yeah.
That's what I did. I used 69 miles between each latitude, multiply that by 113.5, which is 90 plus 23.5. And that gives you the distance around it at the Tropic of Capricorn. Divided by 24 gives you 2,050 miles per hour. And that's much, much faster than, so that would be easy to detect. That's more than twice as fast as it's supposed to be.
See, I've had this argument before. You can't detect it because it's still moving at 15 degrees an hour. So you can't, if it's moving over a bigger area and it's still moving at 15 degrees an hour, then it looks exactly the same.
No, it doesn't, because we're measuring the subsolar point, the point at which the sun is directly beneath. You're measuring how that spot is moving across the Earth. If you measure from subsolar point to subsolar point, you can see how fast that's traveling.
Beneath what though? You said it's beneath. Beneath what?
Beneath the subsolar, beneath the sun. So when the sun's at its zenith.
When the sun is at its zenith, what do you mean zenith? Zenith over who?
Like directly ahead. That means like if you look 90 degrees straight up, the sun's right there.
Yeah, but that will only be the sun will only be over your head if you're living directly on the Tropic of Capricorn.
Exactly.
On the December 21st.
Exactly.
Right. So I don't see your point.
The point is measuring the Tropic of Capricorn. You measure it by measuring how that subsolar point, the point you just agreed was directly above the Tropic of Capricorn. Measure the subsolar point throughout that day, and that'll give you the distance of the Tropic of Capricorn.
But how do you measure it? You just see the sun above your head. How do you measure? What do you measure after that? I don't understand.
You just like two locations, two locations along that same path. Let's say they're 50 miles away. You measure the time that it is when it's at the first place, the time it is at the second place. And then,
how would you do that?
And then you take that distance and divide it by, what did I say? About 50 miles, divided by the time it took.
Yeah, I did all that. And you know what the problem with all that is? The only information you can get about that is based on a globe. So all the distances, subsolar points are based on a globe. You go to time and date or sun calc or any of these kind of things, they're all based on a globe. They're all based around UTC time.
Nothing there was based on a globe. You're measuring a distance and divided by a time.
How are you measuring a distance to an object you don't even know how far away?
No, you're measuring the distance from the subsolar points. So the distance where it's at your zenith, and then the distance to where it's at the other person's zenith at some other time.
Right. And how do you measure the oceans?
What?
How do you measure the oceans?
You don't do it with the ocean. You do it somewhere where it's
but
near you.
The thing you're missing is that it's still going to move at 15 degrees an hour.
That's right. It's a consistent rate. So it's moving consistently.
Yeah, but how can you measure? How can you measure it though? If it's moving at 15 degrees an hour, how do you measure it like that? How do you measure a speed change that way?
Well, if you measure it in 1 hour, if it's at your location right now, and it's at someone else's location in 1 hour from now, then you would measure the distance between you two. If you're 2,000 miles apart,
exactly. And where do you get that information?
You can know it. You can measure it yourself. You can drive it. You can look it up.
Yeah, but where do we get that information from? when people look for that information, where do they go?
Well, I mean, they could drive. You could drive it and look at your odometer.
Right.
Yeah, I mean the
You can do all
distances
that.
on these known land masses, some of them would be hard to fudge it too much. I feel like, you know, because there's roads and we have odometers and shit, and we get it pretty accurate just from your
but
odometer.
the problem with roads is that roads aren't in a straight line. Do you know what I mean?
Yeah, that's what I mean. You get an accurate one though.
You have to look at like it's basically like it's a difficult thing to prove. You look at the analemma itself, what it looks like. You know that it's claimed that the sun is moving faster throughout the sky in the southern summer, yet it's always moving at 15 degrees an hour. You know that airplane flights only up to recent years have avoided, or maybe I think they still are avoiding all the southern oceans. You know what I mean? Why are they doing all this? If it's so easy, if it's just exactly the same below the equator as above, why are all these anomalies? Why is that in the Arctic?
You're a guy. So if you were to do this test from 1 hour to the next, the difference between the two distances on a globe, it should be 952. On the flat Earth you just described, it should be 2050. So there's more than 1,000-mile discrepancy.
How do you measure the 952?
Yeah, 952 on a globe and 2,000 on a flat Earth. On one
and what about the fact that the sun is always refracted? What about that as well?
Well, at 90 degrees, there's not going to be refraction.
Awesome.
And we're not worried about the refracted sun. We're worried about the subsolar point.
Refraction but you have to be, because refraction is going to change what it is when you're seeing the sun.
Yeah, but the subsolar point is going to be one single location. It doesn't matter what magical stuff it's doing. It's the subsolar point. The point on the ground is going to be one single location.
But see, this is what I'm saying. I tried to do all this, and all I could get was globe Earth information. That's my point. But yet, if the sun is supposedly moving faster in the southern summer, and that's the mainstream claim, even Kepler claimed it, moving across the sky faster, yet it's still moving at 15 degrees an hour a day. An hour, 15 degrees an hour every hour of the day. How do you measure that?
I'm not sure why you keep saying globe Earth information when, for a fact, all you have to do is measure when it's your subsolar point. That takes nothing but the globe model, just you making a visual measurement, and then taking a measure of the distance between you and someone else who's doing the exact same thing, which is also not including a globe, and then the time that it takes for that to happen, which you can do with the stopwatch, which has nothing to do with the globe.
Nathan
Those three things have nothing to do with the globe.
Nathan did some of this. Nathan and a load of people around the world got together back in early 2016 it was, and they did something like this to test out whether time and date and these were correct. And they weren't. They were finding that many places where the sun was an hour later than was being said in time and date, and some got all these kind of sites.
Really?
Yeah, you can ask Nathan about that. So I mean, you know, it's like if the sun is out at all, there's something wrong.
That was back in the early days, but yeah, I mean that's true. If you're gonna cite that the flat Earth model that doesn't exist doesn't fit to a clock, then the ball Earth model certainly doesn't. That was back in the days when it was Nathan, Antonio, Patricia Steer,
the guy who got the wrong number.
Flat Earth British.
We lost
Martin.
We lost Adam.
Yeah, he got the wrong number. He was a glober, wasn't he?
I want to address something that was posted. Brian's link. Brian's link doesn't state anywhere that the sun moves faster in the southern hemisphere. I just read the entire thing, and there's nowhere where it states that. Could you please point out where it states that the sun moves faster in the southern hemisphere in the link that you posted, Brian?
Yeah, it said it there. It said it.
Where?
It said it. It said that from our vantage point, I'm not verbatim, but from our vantage point, it would appear to move faster across the sky in January and slower in July.
It was describing a hypothetical.
Well, yeah, but that was describing the orbit around the sun, not the rotation.
And where did he get the sun information from then? Kepler.
Why don't you tell us? You're the one that's making the claim.
Yeah, he got it from astrology. Kepler was an astrologer. He got it from astrology.
Okay, but how does that prove that the sun moves faster in the southern hemisphere?
Geocentric information, and he amalgamated it to the Copernican model. That's why you have a 23.4 degree tilt of the globe out, and that's why it's an offset elliptical orbit where it has to move faster one time a year and slower another time a year and be closer and further at those two particular times.
It says
Yeah,
it right
but the
here.
orbit, but the sun's orbit, the Earth's orbit around the sun doesn't change the 15 degree per hour drift. It doesn't change that.
I can't get you a citation from a university that says that the sun will move across the sky faster in
Because it doesn't. There's no citation that states that. Even your citation doesn't state
Doesn't
that.
it say it right here, Space Pope?
You all
Doesn't
believe in the globe.
Where? Where?
Right in this paragraph that I'm showing on the screen.
I'm not looking at YouTube. Do you mind reading it out for us?
I'm not showing it on YouTube. Look in Discord. I'm sharing it. It says, but the Earth
hang on.
does spin at a constant rate. We see the sunrise in the east and set in the west once every 24 hours or so. But that east to west motion is not constant during the year due to our elliptical orbit. Half the year the sun is moving more quickly to the west, and half the year it's moving more slowly. So if you go outside the same time of day every year and take a picture of the sun, you'll see it drift to the west half the year and to the east the other half, and that's why the analemma is extended in the east-west direction.
Cool.
Right, but it says right here, but the Earth does spin at a constant rate. And what they're referring to is the Earth's orbit around the sun, which is not constant. It goes around in an elliptical path.
It doesn't
But the
matter
rate that
why they say that the sun moves faster. The question was, does the sun appear to move faster across the sky in the southern summer? That was the question.
And what
And where does it state that here, that it moves faster in the southern summer?
Half the year the sun is moving a bit more quickly to the west, and half the year it's moving more slowly. Right there.
How much?
But
is
it says nothing about the southern summer. It just says half the year. So you don't know what in particular they're referring to.
Well, okay, regardless, do you think that they're talking about it being slower reverse? I mean,
no, I just feel like we're
why are you
I just feel like we're attributing something with very little.
I have other links. I'll have to get them. I'm just on my phone. We're just about to go for a shower. Just on my phone, not on my computer. I have other links. I'll try and get them later on. I have them saved from a couple of years ago, where it stated that the sun moves faster across the sky in the southern summer by a certain percentage.
It does.
How much?
It does.
By how much?
It's only by. It only makes a difference of about 15. The combination of the tilt and the change in speed due to the orbit, I think, can cause up to 12 minutes difference.
We don't care what causes it. We just want to know if it moves across the sky.
Yeah, it does. It does. The sun moves
But
more quickly.
Not enough to account for the Tropic of Cancer being 2 times as big on the flat Earth model.
Yeah, but you're looking at it through globe eyes. That's the problem.
The problem is that there's no way they can move according to the flat Earth model.
You're looking at 15 degrees an hour every day. You can't.
Okay, so it's what, 15.1 and 14.9? Close enough.
Yeah, I mean, it's very small fractions of a day. So yes, it's a very small effect.
How do you know that?
Because we can measure how long the sun takes to get to the same position every day of the year, and we know it's just a difference of 12 minutes. We can measure the damn thing. Jesus Christ.
It moves at 15 degrees an hour, yet it is also claimed to be moving faster
12
in the
minutes.
southern summer. I actually read somewhere, Brandon.
No, you've gotten confused.
See if you can find that, Brian. That'd be
divided
very
by
helpful
24 hours divided by 60 minutes equals what?
That the southern summer is shorter
There are
than the
two
northern
things.
summer.
Okay, hold on, Brian. That would be very helpful if you could find that.
There are two things about the rotation of the Earth.
I'll go for a shower and stuff.
Just
Get me
go
cleared
and
with it.
read up on something.
All right.
Right, there are two things that are occurring. One, if you forget about the sun completely and you just measure how the same position of the stars. Now that's always 15 degrees per hour, no matter what's going on, because that's not dependent on the sun. But the position of the sun turning up at the same position is dependent on your orbital velocity. So if you're going more slowly,
we don't want to hear all this shit. We don't want to hear all this shit.
Yeah,
we're trying to figure out how real world observations.
That's what I'm
what's
talking
really
about.
happening. I don't want to hear all this globe shit.
Yeah, it's just reality. Okay, you want to ignore reality.
I just don't want to hear it. I want to talk about how
you don't
we
want to
can
hear
actually.
reality. Okay, you don't want to hear reality.
I want observations. I want empirical data. I don't want to hear all this fucking theory about the globe.
Reality.
Constantly.
Okay, you don't want to hear reality. Okay.
It's not reality.
It is reality.
Empirical data and observations are reality. Experiment, cause and effect is reality.
Yeah,
what you're talking
and I
about
told you,
is your
against the
model.
stars. Against the stars. This has got nothing to do with a flat Earth or globe Earth.
The stars move faster than the sun.
Right. You can measure the movement of the Earth against the stars, and that's 15 degrees per hour all the time.
I agree.
But right, Jesus Christ.
No one is doubting that it's 15 degrees.
Christ.
No one's doubting it's 15 degrees.
But against the sun, then it changes during the seasons because of the Earth's orbit and the inclination. Because it's following an ellipse. There's a dark. Presumably, we're aware of what an elliptical orbit looks like.
Just tell us what we see. Tell us what we see. So, are you saying that it moves more than 15 or less than 15 degrees an hour?
It changes. One part of the year it's more, and one part of the year it's less. And then the net effect, the net is 15 if you take up the average. But
how long does it take, Rumpus? How long does it take the sun to orbit? How long does it take the Earth to orbit the sun in the course of a day? How long does that take?
The course of a day.
Rotation.
Yeah. How long does it take the Earth to orbit the sun in one day?
Well,
just the amount of distance. How much distance would it cover in one day?
Well, it varies depending on the seasons. When it's close,
it's a minuscule distance, right?
Yes, minuscule. Yes, it's not. Yes, the difference.
So how would it significantly affect the speed of the sun across the sky?
Well, it doesn't significantly affect the speed of the sun across the sky. It's only a small effect.
Let me take a shot at it, man.
Yeah, 1.5 million.
However, hang on. However, on the Gleason's map, the effect is drastic.
Oh, absolutely huge. Yes, a factor of 2.
Exactly. So it's accounted for on the heliocentric model. So I don't understand why this is a problem.
Okay.
Yeah, it's a tiny. We're talking about tiny effects here about the speed with the analemma. It's a tiny effect.
Rumpus, you keep on saying that it's only a small effect. It's only this. It's only that. That's all globe out stuff. You observe the sun. I observe the sun. We observe the same exact thing. The difference is our description and explanation of what's happening.
Yeah, but on the flat Earth model, the sun would have to be moving double the speed in the southern.
Correct.
In the southern area.
So what?
Yeah, and how do you know it's not?
Yeah.
What do you mean? So what? That's a big deal.
No, it's not.
So what? How do you know it's not?
Well, why would that be a big deal?
Because it's measurable. It's something that you can be able to see.
Yeah. Have you measured it?
That's what we're doing right now.
What could cause that? How does the sun, something of that size, suddenly go twice as quickly?
Again, Brian talked it off about this. The sky, moving in the sky, you're gonna come back to the ground speed again. So
yeah, it's ground speed we're talking about.
Speed shit, man. I'm glad that we all understand a slightly eccentric orbit around the sun, and then to catch up for the full rotation at different parts of the orbit is gonna be a little different here and there. You know, I'm glad we all understand all that, but it's gonna be ground speed when it comes down to it at the end of the day.
Yeah, Ko shows an example about following the sun at its zenith and following that point. And if you're on a flat Earth and it's at zenith, then it must follow the speed that you're moving. And and that does not change by a factor of 2. So it invalidates the flat Earth model completely.
So you have some real world observations you can share with us, and you've actually done this, looked at it subsolar point across 2 latitudes in the south and compared it to the north. You can show us that empirical data, or?
Well, we can see from sunanddate.com that we know observations.
I'm not interested in sunanddate.com. That's based on your
model. Well, that's
model.
the data. No one of any sense disagrees with that being valid.
No one of any sense. All right, you know what? You fucking asshole.
You're a twat, Brandon.
You're a fucking asshole.
You
can't have a fucking conversation without being a total fucking asshole.
So you're disputing timeanddate.com now, are you? You're disputing the experience people have of noon.
Not
so are
once.
you disputing timeanddate.com or not?
Have you ever had a conversation without being an asshole? Not one time.
Are you disputing timeanddate.com, you moron?
I am disputing it.
Are you disputing? That's outside your mouth, ain't it?
That's how he said it first. He's only responding now. I don't think he was being rude when he said that. He was just saying that he's using timeanddate.com because nobody has shown that it's to be false, and there's nothing.
They have. I only spoke. I showed it to be false. I checked it from my location. It didn't fit my location. The sun didn't do what it said it was doing on time and date. Nathan and a load of other flat earthers all across the world did it back in 2015. I remember it happening, and they found all kinds of anomalies with it.
No, I think that the guy who found that anomaly, the Dutch guy, he was a
No,
troll.
there was a load of
He's
them
a
involved.
glober. He admitted to being
There
a
was a
troll and a glober.
Hold on,
No,
hold on.
no
Is
globers
the
involved. It was all flat earthers.
Nathan did it too.
is the speed is the would the outer circle have to be double the inner circle, or could it just be a little bit faster? Is there a
Depends on
formula
what
for
number
this,
you
or
use. Yeah. The number, like if you use a 24,000 mile radius, like I used in the pictures, you would get it to be about 400 miles per hour faster. But if you use the distance that I forget who it was that used the
so it doesn't have to be double the speed.
well, it would kind of have to be double. I only used 24,000 mile distance because I wanted those maps to look consistent. But the truth is, your equator and your distance to the North Pole and the equator, one of those has to be different than what is known in reality. Because the way that you guys have it, you couldn't keep those numbers the same way we have it, and the flat Earth be a consistent shape.
So from the conversation I just heard, everyone agrees that it's moving faster in the south.
It's moving faster, yeah. That's not a contention.
Okay. Oh, all right.
There you go, Babs.
No. I'm saying I'm saying on the flat Earth. I'm saying on the flat Earth map.
No, I thought you guys were talking about the globe. You said yes, it is in fact in reality moving faster.
He's talking about the based on the orbit. Like I told you, it's like less than that 12 minutes he described before. That's over the course of the whole year.
What is it like? Changes. Are you taking that into account too? Because you're ramming that in there. But the length of the day changes.
The length of the daytime changes, yeah. But the length of the 24
what this
hours.
says right here is that half the year the sun is moving a bit more quickly to the west, and half the year it's moving more slowly.
Right, that's basically the picture I just posted.
That the length of the day is changing if you think about it that way, right?
No, the daytime portion of the day. Like this picture here that I'm posting. You see how this is different days in the year. So on Christmas in the north, it's the shortest day and it's the smallest loop. And that's what they're talking about. They're just saying that it's it's going to be making that circuit shorter or longer.
I'll tell you what, guys. I mean, we just need the fucking empirical, real world observations here. That's what we need. We can talk about this all day long, and we can hear all about the fucking orbits and the tilts and the fucking elliptical bullshit, and we're never gonna get it straight. We're just gonna who can tell the better story. That's all it's gonna be.
Well, yeah, we need some real world. We need some real world data.
I agree with you guys, man.
That data exists.
Measured it. No. I agree with you totally, Brandon.
The only reason we were bringing up the orbits and stuff is because you guys were asking questions about it. But.
No, I get you.
Can I ask Rumpus a question?
No, because he's on mute and he deafened himself.
Oh,
because he's a baby.
Okay.
Yeah, I want to say
he's a scaredy cat. Scaredy cat.
I
was just scared. He's a shook one. He ain't a crook son.
I was watching a thunderstorm earlier, right? I'm trying to pull it up, but it shows the active thunderstorms. I'm trying to figure out how the radio signals picked it up all the way across the earth. I'll pull it up. I'll show it to you, Brandon, here in a minute.
Okay. Yeah, that's interesting stuff. I was actually looking forward to hearing George talk about why we can hear a radio on the other side of the globe and all these bouncy radio waves bouncing off the atmosphere and all that shit. I thought it was going to be a good thing to hear about, but I wasn't responsive enough, so I'll have to apologize. I didn't immediately respond to George on his time frame, so he decided that I wasn't taking it seriously enough and backed out of giving the presentation. That's
going in your file.
Yeah.
Yes,
I'm going about the AE map, y'all. The AE map is azimuthal equidistant, and they keep talking about the azimuth of the sun. If you're gonna make a map, okay, if you're gonna make a map, now let's just take for starters, and you're gonna draw everything as we see it. You can't do that. You can't draw everything.
Yo,
exactly.
No one's trying to make a map, bro.
No one's talking about the azimuth.
We're not making.
I know, but let me get to my point. All right, well, let me get right to my point then. My point is that it's the same thing with the longitude.
The Earth
on
is
the globe. They
flat.
Keep changing sizes. On a flat Earth, the rings keep getting bigger and bigger. The AE map means that you scale it to where each box is the same. so you could just draw it out and have the rings getting bigger and bigger and have a constant longitude latitude. That's the whole point of the AE map, is it's an equidistant map. In other words, each one of them boxes represents the same width on a flat Earth. Okay.
You understand that's
So you
not
have
what
to
they
draw
mean by
the.
equidistant. I mean, it's
Yeah, it is.
equidistant.
It's
They
the
know
azimuth.
that, no, they
It's
mean
the
it's
azimuth.
equidistant.
What do you think azimuth means? Azimuthal equidistant. Think about it.
Yeah, it's not equidistant. It's equidistant from the north to south, but it's not equidistant from east to west. That's what they mean by equidistant.
Let's go up to Norway. Let's go up to Norway, okay? Let's go up to Norway, and let's say that when we're getting further and further north, if I'm going east to west, every degree is only 24 miles. Okay, so if I'm flying from like north, some Northampton to, let's just say, over anywhere in Siberia or anywhere, so you're going 24. It's only 24 miles per degree. So you telling me that an airplane would be curving down 24 miles? No, you're saying
The picture, the picture, that circle I posted, that's the equatorial equidistant, azimuthal equidistant map distortion. So it's distorted east to west, but it's not distorted north to south.
so it's distorted the way the sun goes, right? East to west, right?
Oh, it's just distorted, yeah, east to west.
Yeah, the direction that the sun goes, right?
Well, it's distorted west to east. Is that better? I mean, I don't know why you're bringing up the way the sun goes, but it's distorted.
Well, answer my question. Okay, so if a let's say a blackbird that's going 2,100 miles an hour, if at 69 miles per degree, it's traveling about about a half a degree a second. Okay, it's having to turn nose down. But according to the globe, up in the north, where it's only 24 miles per degree, it's having to transverse a degree every quarter of a second.
I think you're thinking about minutes, not seconds. Yeah. You say second, I think you mean the word minute.
Anyway, on the globe, they're equidistant also, but they don't match. My point is, on a globe, they're equidistant. The radius is the same, but the degrees don't match. Same thing on an AE map. Neither model works right. I just checked it last night, and if you want to go to my channel, and I'll show you 2 points on the same latitude in South America, how it should be about 760 according to the globe model, and it's 985 miles if you do the method you're saying with
how
800.
did you fuck that up?
It's on flat Earth test, and it's I'll show you neither model works, man. They're equidistant models, man. So in other words, the radius is the same up north. Just because the degrees change, that doesn't affect anything.
All right, Brian.
I mean, it doesn't mean anything.
I got it up. Hey, you should use your phone in portrait mode when you're doing this, or turn it sideways.
Yeah, I couldn't, man.
Oh,
I messed up on that one. Yeah, you're right.
Okay.
It's going in your file.
I've been wondering. I wanted to
You
mention
doing flat
that
Earth
to you
mode
before.
again?
Brandon, remember the thunder? I'm sure you are aware of the thunderstorm we had here in Michigan, right? So I was recording it.
Yeah. Go ahead.
Yeah, okay. So I was recording it at that very time. I want Kosho to explain to me how this radio signal went from Australia all the way across the Earth, right here. If you can watch my screen, Kosho, explain to me how it bent around a sphere that fast. That reaction. They're all towers. They're binging off towers.
I posted in chat some relevant.
Look at that. Boom. That was quick. How did it reach that fast?
Where is it?
Yeah, don't they use the radio waves from them?
Don't you know how fast it travels?
I don't see it.
Man, that sucker, it's on my screen. I'm sharing it. I had to screen record it. Because we did have a thunderstorm. And every time that thing lit up in Michigan, right, it actually registered right here on this software. So it was on point. It works. There's no doubt.
Explain to me what I'm looking at again. So what is this site for? What does it track?
It's tracking thunderstorms.
Okay.
So I was watching when we had. Hang on, give me a second. It's coming to it. From right here, it will go. Look, boom. See that? All the way across. How did it do that?
What are the green things? What are the green lines?
That's lightning. These are the towers that are picking up the thunderstorm radar.
Oh, you idiot!
Hundredth of a second, bro. Hundredths of seconds.
The one in Hawaii is going the other way. It's a globe. The one in Hawaii is not looking all the way across Africa, you idiot.
Look how far that's going. Shoo, all the way
You're
to that tower.
complete into
No. Explain it to me.
Wait,
No.
hold on a minute. Wait,
Look,
wait.
No, you're Bon Jovi.
Why didn't they show it going the
Uh-huh.
other way then? Why didn't they show it going the other way? Like I know,
Because-
I know
because
that
they have-
it go across two screens, but I guess
Yeah,
it doesn't
'cause it would
matter
do
how they
Pac-Man
show
mode.
it. They're just showing.
That's the-
They're just
that's
showing
the-
that there was a
that's not-
connection. That doesn't mean that the signal traveled that path necessarily.
It would have to do
Well,
Pac-Man mode.
That's not the only direction though. They do it in other directions that are further.
Well,
too
what's
as
this
well.
website called, dude?
Okay.
Again, let me find it.
All right.
There's more of them
Okay.
that are pretty.
I
Look
suppose-
at that one. Boom, that's pretty.
Don,
fun.
what's this website called? I want to check it out.
It's right. It's called Bits right here at the top. If you can see it.
I can't see small.
No, it's not good enough quality. In Discord. Bitzortung.
Look right there. Watch this one from Europe. It goes all the way straight down.
I gotta try to zoom in or something.
Well, what is your point with this, Don? I guess. What are you trying to?
I mean, does radio waves bend around a curve or something? Like
That's what they say.
It's the skywave.
Yeah, they
Yeah,
think
so
they think
like
that they
that.
bounce off of shit, off of the atmosphere.
Yeah, they do.
Yeah, that's what you say. Yeah.
No, that's what happens. You can do it.
Right.
Yeah, be a ham radio. Study for ham radio license and try it.
I'm aware ham radios work.
Yeah. Well, then obviously not, since you're doubting the fact that it bounces off the ionosphere.
Hey,
how
Sheila,
fast that-
Sheila, I got a question for
Before
you.
we change the subject, let me make one more point, y'all. The Tropic of Capricorn and the Tropic of Cancer are constantly changing.
Yeah, no,
Okay.
I want to go
They're
back to what
constantly
you were
changing.
saying, Brian. I want to talk about your video. So let's slow it down and tell me what we're looking at here.
Yeah, the only thing I want to retract in this video is I said 7 degrees at the end of the video about how far they're moving. It's like 0.7.
Well,
of a degree.
okay, describe. I can't play the sound through the Discord, so just kind of tell me what your whole point is. Walk us through it. I'll play the video and just kind of walk us through what your observation is. All right, go ahead.
Let me see it. Okay, I could just explain it, and you could see the data in the background.
Yeah, that's a
So
good
basically,
idea. Oh, you sound
I
so
took
much
2
better.
points lined up on the 30, between the 34th and the 35th parallel. Okay, and I show that it shows on, according to the horizontals. I mean, on a globe that at 45 degrees, it's like 700 and what you call it miles. That's how many miles. So I take 2 corresponding points. I go to Google Earth and I measure the distance at 805 miles. It's Pichilemu and La Plata, South America. Okay, they're damn near directly lined up. But then if you look at a globe, they're not really lined up. But on Google Earth, they are, according to longitude and latitude. Looks like it's angling down. But to get back to the point, so I measure the time. I go to time and date and check out the times, and it's 51 minutes in between the two. So you already know you got a problem. And if you look at the longitudes, they're 14 degrees apart. So you're already seeing a problem right off the bat. So 14 degrees, 805 miles, and it's not even an hour. 15 degrees an hour would be an hour. We're only 14 degrees, but do the math, and you take 60, divide 51 into 60, multiplied by 805 miles, and you get, I think it's like 965 miles. So that's how far the sun.
Sorry, I just said, were you measuring the sunrise or sunset or noon, or I didn't see what the time difference.
Sunrise.
Okay,
Sunrise.
that makes a lot of sense.
Yeah, that's why I wanted to see. So, are you claiming that fraction for one city and not for the next, or what's your claim? Why is that so grossly misaligned? Because listen, that's like about an 18% difference of what it should be on a globe. That's pretty bad. My point is neither model works.
No, okay, so you went directly north and directly south of one another, right?
Nope, east and west.
East and west, okay.
No, I'm sorry, west and I'm sorry, Coach. West and east.
Yeah, either way. Doesn't matter. This is the same thing. Wait, it was west to east, and it was 51 minutes.
I'm just joking, dude. That was your shit earlier when I said.
Hold on. Just real quick. You said 51 minutes, and how far were the two places?
805 miles.
805 miles. Okay. No, I mean, what's although that is bizarre, I wouldn't do the sunrise and sunset.
And my point is that Kosho, you could go
What was the-
different places all over the globe.
I know, but
You're
what
going
was
to get
the error?
different shit that doesn't match either model.
Why do you say that's an error, though? You said they were 800 miles apart.
Well, because at 35 degrees, you should be at about, what, 760 miles?
You said 35 degrees? That sounds about
In
right.
other words, the continents are they're not they're disproportioned, man, on both models. There are.
Well, listen, you did it at sunrise. That's why.
Yeah, well.
So how far away were the sun? How far apart were the sunrises? I'm pretty slow, Brian.
805 miles. 805 miles, 51 minutes.
805 miles, and it only took 51 minutes.
Correct.
Okay, so 7:07 a.m. must be a different time zone or something, and then 6:59 a.m.
Yeah.
We're looking at two cities. Does it show what the city is?
Or
Pichiluma.
Yeah, La Plata, and Pichiluma.
Okay.
South America. That's in Argentina.
Gotcha. So 7:07 a.m. in La Plata.
Yeah, so 52 minutes. Google Maps.
52 minutes.
Google said 7:08, and that says 7:07.
7:07.
Google's off by 1 minute. And also, I'd like to make one more point, Brendan, that if you just say you're using your eyeball, then you're going to have about a half degree difference. That leaves a 35-mile margin of error. Just saying half a degree, or let's just say a quarter of a degree. Then that's it's about a 17.5-mile error. So with both cities, that would be 35 miles. That would throw off the measurement.
Which is why
on the globe or the flat Earth.
Which is why when you're doing celestial navigation, you don't pick things that are 15 degrees or lower on the horizon.
Yeah, because that makes exactly what I would expect on the flat Earth. But anyways, so let's get back to this. Let's not distract. We can talk about that. La Plata, Argentina, 7:07 a.m. Is there a time zone difference between these two places? Is it an hour apart?
1 hour. So it comes out to you got to match the time. So you got to go to 8:07.
It's 8:07 in La Plata and 6:50.
8:07 a.m.
8:07 and 6:59. So it's actually an hour and 8 minutes, Brian.
No. I'm my bad. I just did it backwards because I lined it up backwards when I wrote it down.
Oh, okay.
It's exactly backwards.
So 7:59 in Chile, or?
Yeah, obviously the earlier time is ahead of the later time. I mean.
Yeah. Okay. So 7:59. Right? Okay, that's where you get that. So this one happened at, we'll just call 7:59 in Chile, right? And then in Argentina, it was 7:07, right?
Yeah, 7:07. Google, and when I looked it up on Google, it said 7:08. So I think I got stuck with that, but that's still 52 minutes. Yeah, we'll go with that.
All right. So it's 7:07 sunrise in Argentina, 7:59 sunrises in the other city in Chile.
Yep.
Right?
Yep.
Okay. And you're saying it's 52 minutes apart, and it's how many degrees?
Yeah. It is 14.
14 degrees. So 52
it's
minutes.
Like, yeah. 14.
Okay.
It's actually 13 7 or something. No, it's just 14 is good. It's just barely over or barely under 14 degrees.
14 degrees. Gotcha.
You see a little part where it says it's rising at a heading of 83 degrees and not 90?
Yeah.
Yeah, well, that's important too, because what you're doing.
Yeah, that's a whole nother problem for the globe.
No, a whole nother problem for the flat Earth. Sorry.
If it's 83 degrees, okay, then and 90 would be on the equator. So if I'm tilted over at 35 degrees, okay, why would the sun be only 7 degrees? If I could give you half, and say could be 17 degrees.
No, you don't. You don't. No. Okay, no. I'm sorry. I'm not here to teach you basic.
In other words, if you're standing upright
mechanics.
and you didn't drink your B8, and you start leaning to the right, if you lean all the way to the right, 90 degrees, the sun's going to be 45 degrees to your left. So I can give you half and say it should be at 17 degrees off of 34 degrees. But it shouldn't be only 7 degrees off. That's another globe anomaly, in my opinion.
Brandon, check your.
that angle doesn't matter in the morning, man. That angle is the local solar noon. So the local solar noon, depending on where the sun is directly over, then your latitude is going to matter. That 35 degrees, you'll be able to use that and either add it or subtract it to your 35 degrees to get the elevation at the noon. But in the morning, it's not gonna be the same height. There's no point. That's what I'm saying. Doing it in sunrise or sunset, you're not going to get any kind of, you're not going to.
Yeah, but
you're
you're calling. Listen, man, that's the problem though. You're calling it 83 degrees, but you're saying that the sun is 83 degrees, but then you're also saying that you're 35 degrees down around a ball. Okay,
So
that doesn't match, bro.
And
I-
actually,
I-
it does.
said that.
Actually, it does. I've seen it done on globes. It actually works quite well, and it's unexplainable on a flat Earth, especially when you get to Australia.
No, like I said,
La
if you
Paz is
spin all the way
La Paz
to the
inside?
right,
Is La Paz inside the tropics? It sounds like it is. I don't know.
No, but his locations.
Yeah.
No, his locations are outside. She was at 35 south. He said.
Okay. Thank you. I missed that.
So you're saying the fact that this isn't a subsolar point is throwing this off?
Well, no, it's not that it's not a subsolar point. It's that it's in sunrise. It's that the degrees, like it's at 35 degrees south. That degrees is only going to be relevant. That you can make a relevant prediction or measurement based on that local solar noon.
let me ask you a question, Coach O. If I'm on the equator and I see the sun at 90 degrees east, sunrise, okay, and I go 69 miles south, what is the sunrise going to be at then?
Well, if that happened, you would be on the
Half a degree,
equator.
yes, half a degree. So it's at 34.
No, I didn't say half.
It'd have to be 17.
Oh, by the way, that only happens
Yes,
twice.
I'm telling you.
That only happens twice a year, you know, right?
And when it happens everywhere in the world. So
Yeah, it only
No,
happens
it
twice
don't.
a year, by the
No,
way.
it does not.
yeah, when it happens
What are
for
you talking
you,
about?
when it happens on the equator, it happens for everywhere in the world. Any locations.
No, it doesn't, man. Okay, how
On
could
the
it? Okay.
equinox, it sure does.
That doesn't work on a globe, dude. I know it happens
Equinox.
in reality, but on a globe, okay,
Actually, it
line
works
you
on a
up some
globe.
sticks, okay, and go by the freaking analemma. If you're tilting, well, okay, if you're tilting away,
It's the equinox.
neither model works, bro. I'm telling you, man.
No, actually, the globe does work, and you just don't understand orbital mechanics well enough to understand it. I'm sorry.
Okay. If I'm tilting away from a guy I'm holding hands with, okay, then we're gonna have different shadows, man.
Why are you holding hands?
I wasn't gonna go there. I wasn't gonna go there.
Just messing around.
Oh my god. I don't understand the problem with this still though, because it's 14 degrees 52 minutes. That makes sense. 14 degrees and 52 minutes. It
Okay,
should
now
be.
look, now look. It's claimed that at 35 degrees, that it's okay, at 45 degrees, it's 735 miles, okay, per hour, basically. So that's the distance. Hold on, let me get it. I think it's I wrote it down. I got a globe right here. As you go down, in other words, if you get all the way to the South Pole, it's gonna be 0.
Yeah.
Okay, so it works its way down on a globe.
Okay.
All the way down to 0. It works its way from 69 miles per degree down to 0 per degree.
Okay.
If you want to
So Brian,
hold on, let me get my globe.
How far for these two locations should it take for 14 degrees?
Okay, hold on. It should take. Hold on. I didn't do it like that. Okay, the model says. Hold on. Let's grab this globe.
Okay.
34 degrees. Okay. Here it is. It is. Damn it. I hate it when every time I try and rush, it slows me down. Let me slow down.
Yeah, slow down. Smooth.
Okay, here it is.
Slow as smooth. Smooth
Okay,
as
so
fast.
it's 69 miles at the equator. Okay, at 10 degrees, it is
69 miles at the equator per degree. Okay.
yeah. Looks like 50 or.
Why you're working
Hold on, let me get my glasses, man.
While you're working on that, it's an interesting exercise. But if you go to any location, there's thousands, millions of locations in the world. Go to any location, timeofday.com. Go to September or March. Look at the 21st or the 23rd. You're going to find that every single location, the sunset and the sunrise are going to be east and west.
Okay, here it is. Here it is right here. Okay, so at 34 degrees, it should be about between 54 and 55 miles per degree. Per degree, okay?
Okay.
So 14 degrees, okay, times 54?
54.
Multiply that.
54 times 14?
Yeah.
540
756.
Yeah, that's what you're supposed to have.
And it's 805?
Okay, look at, yeah, and we wind up having like in between 900 and 1,000. It's off a good bit. And you know. Brandon, there's no getting around that, man.
It's pretty close though, Brian, because you're saying it's 805 here. According to this.
Yeah, 805 is the actual miles per 14 degrees when it's 15 degrees per hour. Anyway, you know how you do the math? You divide. I did 51 because I went to Google and for some reason I had 708 stuck in my head. But even 52, so take 60, divide it by 52, and multiply that times 805, and you don't get 735 miles. You get like 950 something if you use 707, 708. I don't know why I did that.
Try this out, man. Just whenever you do this next time, just do the same thing, but for noon instead, and you'll get infinitely less problems.
Now, I would like to say one more thing. Okay.
Okay.
Now, when they tested the globe, Nathan Oakley's, Brandon, if you hadn't seen it, go to Nathan Oakley's playlist, and it has the, you'll see where they were doing.
I was looking for that. I couldn't find it. Do you know which playlist it's in?
It's tedious, man, because they did it all over the world, and they did it for like a week. But the playlist, I think, is called the 24-hour sun, measuring the sun.
Yeah.
Or the sun angles.
I remember seeing it at one time, but I can't
you'll see
find
some
it.
long experiments, and they showed that all over the world, the time and date does not match the model in reality. All over the world, it was off by over an hour in some places, but it was. And
the guy who was off by an hour was in Netherlands, and he was a troll, and he admitted to it.
No, it was off everywhere though, Kosho.
But it's a bit of a tautology to say the sun rises east and west when the sun would go east and west anyway, following the course of the sun. So it's a bit of a useless tautology to say that. And also, there's time and date data for everywhere except McMurdo Station and anywhere south of that in Antarctica. So we don't really know even what's going on down there with this east-west, sunrise thing. It appears to rise, differently depending on what area you're on the flat plane, depending on where you are locally.
If it was flat plane going around in a circle and you were south of the equator on the equinox, the sun would appear to rise northeast and set northwest because it's making a circle in front of you. You're outside the circle. But what happens is everywhere on Earth, it rises from exactly the east and sets from exactly the west.
But I put the chart in Jose's Hangout where basically when we read something with a compass, we draw straight lines in our mind that are like a plus sign grid for north, south, east, and west. We believe that there's this line going infinitely toward the north, infinitely toward the south, and infinitely straight toward the east and west, when that's incorrect. At best, east-west are circles following the sun as it circles in and out of those quadrants that you arbitrarily draw north, south, east, west like a straight line. And so your bearings are going to be off based off of that. I'll put the drawing in the chat that's kind of illustrating what I'm talking about.
Yeah, you got to take perspective effects into account too, right?
Yes.
Perspective would do there, particularly the fact that you are, no matter what position you are, it's east and west. If there's a circle that the sun's making, and you're in front, if you're inside that circle versus outside that circle versus on that circle, it's going to appear to do all sorts of stuff, let alone not go directly east to west. In some places, it'll go.
That's due east, man. If you go compass east, I went out there on the equinox, and this is the first video I ever did, and we did a string. Okay, it does not line up with compass east. It lines up with due east. That works on either model.
I put it in the chat. Basically, you have a bullseye on top of a circle. What were you saying?
I was going to try to explain this, but I'll bring up your thing because you started talking about it. Which chat did you put it in the general?
General at 657 under fifth assist. This graphic illustrates how the sun can circle east to west over the southern tropics, yet appear to be north of due east according to a compass reading. East to west would be read as a straight line on a compass, while the sun would move east-west in a circle overhead. That would move in front of and behind that line. So basically you have a bullseye on top of a circle. And the sun could potentially circle in front of or behind the arbitrary lines that you draw. And with perspective and refraction, it could get even crazier.
So
yeah, that's what I
let me
think too.
understand
Because
what you just said. Wait, can you put that picture back? Sorry, Brandon.
yeah,
Just taking a look at it, I didn't really understand how he was able to make some kind of. Okay, yeah. So if the sun's making that path and it's making a circle at the center, and during the equinoxes, it's over the equator. If you're somewhere like at the southern southern Africa, south of Australia, and you're viewing the sunrise and sunset, it's never gonna appear to be coming directly east from you, because directly east from you is gonna be, pointed towards the wall, south somewhere. It's gonna be coming from the northeast, right? Because it's going to be in front of you.
Well, which east are you drawing? Are you drawing the bullseye east, which you're tempted to make a straight line, or the east-west circle that follows the sun as it circles over the flat plane?
It wouldn't matter. It wouldn't matter. I'll show you. I'll make a picture of them.
Because potentially the sun can circle into any of those quadrants that you arbitrarily draw based off of your local position.
Yeah, but then east wouldn't be opposed. So east and west are directly on the opposite sides of each other. So if you were doing what you said, then east would be in front of you and west would be in front of you, and they wouldn't be opposite of each other.
If you trace it as a plus sign bullseye, yes. But east-west, technically, if you want to get technical about it, is the circuit of the sun as it circles overhead. It just follows the path of the sun.
Right. I'm saying that if you're watching sunrise, then you're staring straight at the sunrise, and you point your chair pointed directly at sunrise. Then at sunset, you're going to need the chair to be pointed exactly turned around and pointed in the opposite direction, 180 degrees. This is what I mean by back to front, front to back.
But if you do a line like that, your line's going to point off into space, and potentially it could go totally away from the path of the sun. You would need to draw a plus sign at noontime to get your quadrants right to see how the sun is going to circle in and out of those quadrants, and then you'll have some proper bearings. But at best, you could only do that at noon or at noon to get the best north, south, east, west straight line quadrants as the sun circles in and out of those quadrants wherever the hell you are.
Right. So what I just said was you don't have to do it at noon. You can do it in the morning. You can put anything facing the sun in the morning, and it's gonna be facing the exact opposite side at night. That's what's gonna set.
Quadrants are going to be off.
Degrees. That's not wrong. That always happens.
Your quadrants are going to be off. You need to do it at high noon. That way you're in the middle of the day with your quadrants nice and centered. If you do it at sunrise, your plus sign is going to be skewed. So you need to do it at noon at the very least to get the most accurate headings.
This is done every day. I mean, every year, like the equinox, like people know that it's directly east and west and they're opposite sides of each other.
Here, can I show you guys something? So
yeah, go ahead, man.
Here's what I mean by I think perspective would impact it. So this is the equator. Okay, just outside of the white circle is the equator. I'm standing right here and I'm observing the sun on the equator. If I'm looking, what would this be? West, right? Let's just pretend the sun's coming from here. And the sun was here and it was coming this way. Everything along this triangle, if I drew a line down the center of it, anything on the outside of this triangle, like this, is going to look like it's in the center of this triangle. So if I'm right here, if I'm looking this way, anything in this triangle is going to look like it's in the center of this triangle as it gets closer to me. You understand what I'm saying?
Anything on that line, you mean?
No. Anything in this triangle. If something's right here, it's going to look like it's right here.
We can't see your cursor, remember?
God damn it. If it's on the outside of the triangle, if it's anywhere on the triangle, here, I'll draw another line.
Sorry.
All right. I don't know if this is true. This is just what I was thinking about. Do you see that white line?
Yeah.
Okay, so let's say there's something on that white line. That whatever's on that white line at that distance is going to look like it's on the center line, no matter where on that white line it is.
Put it somewhere else in the white line.
I'm sorry?
So I know which line you're talking about.
Huh?
Put it somewhere else in the white line just so I can see, because you said no matter where it is in the white line.
Yeah.
I'm
So
trying to see which white line you're talking about.
if it was here on the white line, if it was here, it's going to look like it's here.
Why do you say that?
Perspective.
That's not what perspective does, though.
Yeah, it does.
If something's in your center of your vision, then it's going to be in the center of your vision, regardless of where it is. But if it's not,
if it's on the center of your vision, if it's outside, the further away it is, the closer to the center of your vision it's going to look. So if it's far enough away and it's over here, it's all going to look like it's right here.
No,
Yeah.
if it's the other way, if it's at the end of your triangle, then it's going to be at the end of your vision. Like if you no matter how far away it is, if it's at the end of that triangle, it'll be in your vision. You'll see it, but it'll be at the very end of it, like on one side of it or the other.
No. At some point, I don't know how wide this triangle it is. No matter where it is here, it's all going to squish into the center of your vision.
Well, by perspective, if something stays at the same elevation, it'll appear to approach the level of the eyes. So
That's
it
just
could
up
be,
and down, though,
staying at the same.
right?
Yeah.
That's just up and down, but there's that center effect too.
Well, if the sun was circling in front of you, if it's coming from a great distance, eventually it'll rise up over the horizon and then kind of ramp up to the middle of your vision and then ramp down toward the other side as it goes further away. Like looking down a hallway, but the hallway's kind of to the side now, or you're looking down a hallway kind of to the left or the right.
Right. Well, just like this. It's just kind of think of this in the reverse. This right here, think about this. This right here, this left one right here is all the way over here in your vision, right? But it's all in the center. These trees are off to the side when they're close to you. When they're further away from you, they're all in the center of your vision. Everything squishes into this focal point, sideways and up and down.
Okay, so you're saying something different now. Because go back to your other picture for a second.
No, that is what I'm saying. Maybe
we see in a cone of vision.
Yeah.
We see in a cone of vision. I don't know how many times I've told it to you. We see in a cone of vision.
Check this out. Go back to
Everything goes into a convergence point.
This is that's what I'm trying to describe here is this convergence point. So that's why I think that you would observe the sun if it was traveling in whatever that relationship is, which I think it's what is it called? There is a mathematical relationship, like the perspective. It's it follows the inverse square, right?
But Brendan,
so it would if it was moving along here, it would all squish into this center convergence in your vision. That's where you would observe it, and it would look like it was coming straight at you.
Okay, Brendan, check this out. If you were looking at this thing right here, where would the railroad be along this line? It would be along the line.
Which thing?
Right? It's not gonna, the railroad isn't going to fan out like that. Like the railroad is in a straight line in front of you.
Yeah, I know that. Everything in the center is still going to be in the center. Everything off to the side is going to be in the center. It's all going to converge in the center. The further away it is, the more it converges in the center. So it doesn't, if it's this far away from the center out here, it's going to be in the center. If it's this far from the center out here, it's not going to be in the center. It's going to be offset. But if it's right here, it's going to be in the center. There's a mathematical relationship that will converge it into the center of your vision, and that's where you'll see it, but it's not necessarily in that direction. That is how our vision works.
Can you describe what this picture is supposed to represent one more time? Because maybe I missed something. Because if it seems like that's supposed to be the actual, is that the actual distances that they are from him? This triangle?
No, I mean, this is like on a fucking Earth scale. This would be the equator. I'm standing here on the equator. So this is like 6,000 miles away. That's why, it's moving so far into the center of your vision. 6,000 miles. That's a fuck of a long way. So he'll see it here. If he looks east or west, right? It'll converge here. And then as it gets closer, it's moving in an arc anyway. So it's following that mathematical relationship, and it's going to be right here. No, not making sense.
No, I don't understand. Like, is that triangle supposed to represent an actual space? Like that's his actual space of the range you can see.
This triangle covers actual space, right? You can think of this as an overlay on top of geometric space. But what it is supposed to show is that anything within this cone, we'll call it a cone, is going to converge into the center of the vision. And that relationship, the further away you are, the wider the area that is going to converge into the center of your vision.
I think actually what is happening is that where that cone is a cone, you're going to see further and further as you look further and further. But if looking right in front of you, you can see, 6 feet on your left and 6 feet on your right, something that's like 3 feet in front of you. Like you see a wall 6 feet on your left, 6 feet on your right. That's the extent you can see. Then that same range is going to be like if you could then see like miles and miles and miles, it's going to be zoomed into that 6 feet on the left and 6 feet on the right, but it's not going to be in this very center. The only what's in the very center is going to be in the very center.
All right, you can think of it backwards too. So let me flip it maybe. This widest space is going to converge down into this visual space. Okay. So if something was here and it was moving parallel to this line away from this man, he's going to see it here. No, that doesn't make any more sense.
Have you been talking to me that whole time?
No, I'm just no, I'm talking to Kosho.
So the way that I do it would be like the P-brain perspective video where you have the two triangles, centered at the observer, but you know how you have that point kind of reverse it, rotate it 180 degrees, and then you'd have to have another triangle like that on the other side. So basically you'd have like a big flattened triangle made of two triangles, one to the left and one to the right. And the sunrise would be it kind of angling up out like a triangle toward the noon position, highest up, and then angling down toward a sunset. And that would be what you're talking about, with like the train tracks kind of rotated to the left or the right. So I'd take that triangle and rotate it to the left.
I posted a horizon picture as well, but even in this one, like you can see more stuff as you look out. The mountains are further out, but your frame is they're not moved to this. They're not the whole thing. That's all that stuff that's further away. No matter what side of the frame it's on, it's not going to be in the center of the frame. It's going to be still on that side of the frame.
No, see, this is what I'm talking about. That's why I flipped it around, Kosho. So if I flip this around, this right here represents this line right here. Okay. And these yellow lines represent the side of the road. See how the further it makes a triangle, right? But these are in actuality extending parallel to each other out. That is converging into the center. Now, depending on how far you go, the more it'll converge. If this went on forever, it would just look like it would all converge right here in the center line. You wouldn't be able to tell anything out. So there's a mathematical relationship that is based on distance and it's offset from the person that will converge things into the center of their vision. That's what I'm trying to describe right here. So that same thing would happen with the sun is it has to follow that same mathematical relationship. So 6,000 miles away, its arc is going to follow that mathematical relationship, and you're going to see it at some point during its circuit above us coming as a straight line towards you.
That doesn't happen though.
Of course it happens. Look on this road right here. Okay, so
No, I mean,
here's the red dot on the little diagram, right?
I was just meant with the sun, I meant.
Oh, well, that's what you say. It doesn't happen with the sun, but I'm trying to get this idea across from you what we meant by perspective would impact it, right? Because this little red dot would be this red dot, okay? As it moves away from you, it's still the same distance from the center of your vision, but it's converging on the center of your vision, just like this red dot is converging on the center of your vision. That means the inverse is true. When I flip this around, anything that is over here, this distance away, is converged into the center. And if it follows that mathematical path, which is circular, it is a circle, it would look like it's coming directly at you from the center.
See, that's the part that I'm bothered by, is because if you look at the ends of the triangle, the ends of those triangle represent the two ends of the frame. So those two ends of the frame are always going to be the ends of your frame. They're not going to be the center of your frame.
No. Okay, think about it this way. This space right here, right? If I drag that out.
Don't forget, we can't see the cursor, but I think I know.
Yeah, let me.
I think I know what you're talking about.
Right on this picture, if I took this out and I in actual just made these parallel, right? Like I put one right here, and I put one on the other side, right here. You're right. The distance between that visual space is a fuck of a lot longer at the end of where I can see than it is right here. That's what is represented by this triangle. This covers a ton, but it's converged into the center, right?
Yeah, that's what that triangle. That's what that triangle represents. That triangle is that 6 feet. So you don't even have to make a new area of it. Because whatever that triangle's, whatever distance away from him it is, whatever it's covering in the picture is his frame of view, and so he can't see outside of that. So the 6 feet or whatever the distance is close to him is already represented in that triangle. Everything that you can see is represented in that triangle, and the side walls of that triangle, the two lines on the sides of that triangle, are the edge of his frame.
Do you understand, Kosho, that it's the convergence?
Why are you telling me what I'm representing in my diagram? Do you understand the idea that I'm trying to get across or not, Kosho?
He does. Is that triangle supposed to be his frame of view?
Because it seems like I'm just going to tell you what it seems like, and I'm not trying to accuse you of anything. It seems like you're being willfully ignorant at this point.
No, I mean, if is that triangle supposed to represent his field of view? Because if it is, then we're on the same page.
No, it's not his field of view. It is the cone of convergence, we'll call it. Anything within this
ding,
cone
ding,
of
ding,
convergence.
ding. He won't answer, because at the end of the day, when he's asked what the apparent junction of the sky and ground is, he'll be silent, as documented.
I mean, you can see it right here. You posted a picture that represents the cone of convergence perfectly. Okay. Anything within this cone of convergence is going to converge into the center.
Okay. So you cannot see anything outside that line, or you can see stuff outside that line?
Of course you can. Of course you can. This just shows. Yes. But if something was outside this line, like say something was over here.
I see. Okay.
Right. It'd still be outside. It would still be outside of the center. It would just be closer.
I understand. So you can see outside that triangle, then the triangle's not your frame of view.
Yes, he can see anywhere. He can see. I
thought you were meaning that triangle was your field of view.
No, this is like a perspective cone of convergence. That's what this is supposed to mean. But I get I understand where you're confused.
Yeah, so that triangle is supposed to only represent the center line.
This covers the geographic space that he will see as converged into the center of his vision.
So you can even say that the yellow triangle there would be probably the yellow lanes in the one I posted. Like it could just represent those yellow lanes. Because it would be doing that.
Exactly. Yeah, these yellow lines, if it went far enough, look at the end of this yellow line right here, this right here. Think of how much of this mountain fits into this same visual space, right? It's all converged into that visual space.
Okay, that's fair.
It's a whole.
No, we were on two different pages. I thought that the triangle was supposed to represent your field of view. I didn't realize you were. It was only supposed to be a narrow point of your field of view.
No, I'm glad you clarified it, because there was probably other people that were confused too. Okay. So that is how it could look like something is moving directly at you, but actually, in actuality, it's not moving directly at you at all. I mean, you could follow that mathematical relationship if you plotted a path out and followed that mathematical relationship for how we see how the world is represented in our vision. And it's not just our vision with camera, whatever. That's just how light works or how space works. It's just the fundamentals of optics. If you plotted something along that path, it would look like it's coming right at you.
Can I ask a quick question?
Yeah.
Would it also affect the angular size of the sun?
Yeah, I was going to say that.
Yeah, in theory, but you're looking through more and more atmosphere the further away it is. So hard to tell what it should look like, what size it should be, you know.
But then you wouldn't get the cone because that would affect everything, right?
You wouldn't get what?
No.
In fact, Kepler could measure the apparent size change of it with 2 pinholes and passing the sun through these 2 pinholes, and he's able to calculate the apparent size change. So if Kepler can do it, and he can write about it and give you the mathematics for it, then there is an apparent size change to the sun. The argument is that it's supposed, according to your flat Earth model, it's supposed to disappear because it's operating on a terrestrial concept. The point is the convergence happens at a very small distance for a 6-foot observer.
Go over what you just said about Kepler. He did this in a single day, or he did this over the course of a year?
So why don't you go look up Kepler's optical...
that have presented it, they ought to know what he's talking about.
I'm not your babysitter. You can bite my...
Yeah, he didn't do it over the course of a day. So let's go ahead and nip that in the bud. The change is over the course of a year.
Function.
He's measuring it with his eye. He's measuring it with his eye with 2 pinholes. Give me a break, fellas.
That's right. So what? You just got it very accurately. Thank you.
Yeah. What was this?
Follow a squared function over a day, right?
What did you say? Who was that?
Yeah, what were the results of that observation?
Mailman?
Rob Skiba does a video on magnification, on how the sun, not always, but most of the time, keeps its angular size because of magnification.
But that magnification would affect everything, your whole cone of vision, not just the sun.
Well, when you do it in the desert, when he does the experiment in the desert, the sun disappears above the horizon because it shrinks so small.
Yeah, but Mailman, there's not very many things we can see that are as far away as the sun. Like even these mountains. How far away these mountains do you think these are? This is probably like 20 miles away, right? 50? I don't know. It's been a while since I lived by the mountains.
Oh.
But
how much did
the
they
sun
reduce
goes
in size?
6,000, 7,000 miles away from you, and you still see it. So it's going through a lot more atmosphere than anything that's close to you, and it's getting a lot further away, so the dynamics are going to be different.
So it should be magnified and magnified even more the further away it goes?
No, I don't think so. I don't think there's a linear relationship to it. I don't know what's happening.
It's almost as if they negate each other out, and it keeps its same size. But when you do it in dry climate, like the desert, you'll literally see the sun get so small, it disappears above the horizon.
Oh, do you have
But here's the thing. You guys are calculating the concept of tangible items that are reflecting light versus something that's producing the light.
Yeah, the globe response to that would be just make things
All I'm saying is
astronomically
that
far
it
away
is
and
true
astronomically
that
big, right?
The only thing I was getting at is there is angular size in the sun reduction, angular size reduction in the sun, depending on where your experiment. So much so that it'll disappear above the horizon.
Proof from the citation.
Yeah, I seen it on Rob Skiba's.
No, we have lots of
I
videos
see it on
of
Ron
that happening.
Skiba's. Yes, okay, that's good enough for me.
We have multiple observations of that.
That's my proof. That's it. That's
Ron
all I
Skiba,
got.
good. Okay.
Doesn't matter who it was. We've got observations of that taking place.
Uh-huh.
You do
Yeah,
literally
all I'm
watch
saying is
the
the
sun
person that
disappear. Now you want to blame it on the sensor. You want to blame it on whatever
or the-
else. It does
you want to
appear
blame it on the
disappear.
person I trust.
Well, give me a link to this proof, please.
I don't have the link handy, but this has been.
You can do it to yourself. You can do it to yourself. Go get a sheet of
Why would you just do the same thing you're claiming I did? Why wouldn't you just do the experiment yourself?
Well, I need to see the experiment first. This is the first I've heard of this.
Well, you're
I'm
gonna
serious.
watch it on a video, right? If you're not gonna do it, you're gonna
Oh, no, I
see
want to see
somebody
it.
else do it.
I want to see the experiment.
Hold
I've
on.
never
The
heard
sun
of
is
this.
independent to the observer. The sun is independent to each observer. That's how they have. I mean, you look at the latest sun in the cloud videos and shit, and they used to say that it's because the brightness of it's blocking out. You can't deny that now with all the hydrogen alpha filters and all that shit. The sun is local to the observer, man. It's independent to each observer.
Here's the thing: we've all watched the sunset. We've all watched the sunset, and we all see the same sunset. The sun does not appear to disappear; it sets and goes below the horizon. We can't argue that. You know, come on.
Yeah. Okay.
It goes in.
It
goes into the convergence.
No, that's not
It
how
goes
it
into
works.
the convergence point of the
Incorrect.
eye.
How come?
That's
How
what
come
it
the?
does.
How come the sun
I'm
only?
the only one
Why is
that's
the
gonna
sun?
say. I'm the only one that apparently can quickly say that's not true. I have a gift of it doing exactly what you said it doesn't do.
Yeah, let's show that shit because I was just looking for it too.
I got you, Brandon. Give me like 60 seconds.
Cool.
Which
Yeah,
is a
picture
globe
the-
killer. That'd be a globe killer. You know, if you want to look at it like that, you think everything is a flat Earth model killer. You know, just like we could say, hey, this is a globe killer. The possible eclipse kills the globe. You can't have a globe. That's what
it's
you do
not
with
only-
flat Earth.
It's not only that. It's like I can't stand the inconsistency, because if you're gonna say, yeah, you know, sunsets, you know, if all of the bodies, you know, go from east to west because the Earth is rotating. Okay, well then what about moon sets? What about star sets? Everyone's concerned about the sun that doesn't always appear to set, quote unquote.
Moon rises and sets in the same way. Why? What's the problem?
Yeah, when the stars and moon do the same thing.
Stars do the same
Anything
thing
over-
too. They rise in the east and set in the west. What's your problem?
I can't even Google a proper moon set.
Yeah.
How about while I'm looking for what I'm looking for, you post like a.
You need to
and then,
find when the
a
moon is
picture
directly
of-
over the equator, specifically to see it.
Not
Everyone-
about what I listen. I can go to the beach and watch a quote unquote sunset whenever I feel like. Like I want to do the same thing with the moon. Are you telling me it has to be a special situation? Because okay, so if not, if you could find me that moon set picture, that would be great.
Yeah, the moon is a little bit further south and a little bit further north than the sun, this range. And so what that means is that it's going to do the same sort of thing as the sun does. It sets and rises generally in the east and the west, but only if it's over the equator is it going to be exactly in the east and the west for everywhere in the world. So
Yeah, I'm not denying any of that. Do you have a picture of a moon set in the way
You
that
have a
this
picture
guy
of a
just
moon set?
described
Are
the
you serious?
sunset?
You've never seen the moon set?
this is every night, man.
Look, post it for the audience sake. I mean, come on, don't be stingy.
Oh my god. Let's see how long it takes me. How long do you think it'll take me to find a video of the moon set?
30 seconds, 25 seconds, maybe.
Something like that.
Awesome. Then just fucking do it. Shut the fuck up.
It's just amazing that you guys can't find a video of the moon set.
Who said we can't find it? Just find the fucking video. All right. Now, somewhere in here, there is the sun disappearing. This is the DITRH one that was mentioned.
Oh, this is Earth?
Yeah.
Yeah, well-known scientist.
We're talking about an observation. We're looking at a piece of video. That's all we're doing.
I gotta tell you something. We can do it before or after, but when you look at videos with the sun setting, pay attention to the type of atmosphere that's there, because something's gonna happen with the aperture depending on the amount of like clouds and haziness and that kind of stuff if you don't have a clear sky. So just pay attention.
Oh, so the clouds and the haziness are going to affect what you see.
Yeah, based on your camera settings. Yeah.
Oh, it's just cameras that are impacted by the clouds and the haziness. They don't impact what you see with your eyes, right?
Yeah, absolutely.
Oh, that makes a lot of sense, Kosho.
Like, the sun's not going to appear to shrink in your eyesight, but it will on your camera and dim and then disappear because of the settings on the camera.
Backpedaling.
I've seen somebody do an observation with their camera, and then do the same observation at the same time with a solar filter, and then play them side by side. And in one, it does appear to shrink, and the other, it doesn't.
That's a nice backstroke. Okay, so before I post this, because I did send it straight to Brandon by mistake, because I don't know exactly where, because I shared it directly from my phone, and then I was looking through the list. I don't know exactly what the Discord's name is and where the room is, but anyway.
I got you.
So, Guy, based on what Kosho is saying, you know, adding those other elements that are obvious, are you going to take back your statement that you can't see a sunset where the sun appears to disappear into the sky?
I just told you, you're not going to see it with your eyes. These observations and these cameras, they're only done because of the camera settings.
I don't think
so.
so.
No, we don't let the sun flare. Hold on.
I don't think so, because the video that I posted is I mean, honestly, I don't have any pedigree information, so that's probably necessary, but I could probably hunt it down. But it's a Chicago sunset, and I got it from Fox, I believe. And I don't think they said this is a rare sunset. So but it's only rare if you pull out your camera and video it. I don't think that was the thing. I think it was a rare sunset because it was a rare sunset.
Wait, they put this on the news?
I think they only call it a rare sunset because they can't say, hey, the sun not getting cut in half by the horizon isn't, you know, they can't just say that's a normal occurrence and it has to do with the atmosphere and the angle to the ground along with that.
Are you saying this was on the news?
Yeah.
Okay, let's see this video.
So I just posted a video for you guys. I just did a quick little demonstration showing you that the circular object will stay the same size but appear to refract downward as I move in a straight parallel line. Brandon, I'll tag you in the video. I just posted it for everybody to watch.
Where'd you post it?
Did you share that? You share it with I'm sorry, Elijah. Did you share it with Brendan, the one with the news?
Yes.
Oh, I see it. Yeah, I should be playing Elijah's video on my screen. I played it a few times.
Is that from the news? Is that from? Looks like this is like somebody's video. This is on the news.
Yep.
See, the one I watched, they also used the sun flare lens, and the sun did set, right? But in using
so the sun goes behind clouds, and you're saying that that's sun setting?
Yeah, that's not a good example.
No shit.
Oh, he's saying that's on the news. Also, I don't think that's on the news.
So this is something that will show as it moves away. It does not change. This is something I shot 2 minutes ago.
When they use the sun flare lens, it showed the sun shrinking.
I'm listening to it there.
I just shot this video like 5 minutes ago, and it will show you that objects will keep its size and appear to go down due to refraction.
It's not keeping its size.
What, you got a Fresnel lens there?
Is it cut in half by the horizon?
So where's the Fresnel lens in the sky?
So again, it's just demonstrating that
where's
the size.
The fucking Fresnel lens in the sky?
The atmosphere, the lens, the water.
No, the water. The atmosphere is not a Fresnel lens.
Wait a second. Hold on now. Are you telling me your model doesn't explain?
The atmosphere is not a Fresnel lens.
Let me tell you something.
My fucking God, you have a Fresnel lens here, and you're saying that this demonstrates the Earth? Show me the fucking Fresnel lens in the sky.
Do you see the sun?
No, listen. Show me the Fresnel lens in the sky.
NASA show, look outside, you see it every day.
No, sorry, there's no Fresnel lens in the sky.
No, we see it every day.
No,
you just
no
look
Fresnel
outside.
lens in the sky, you moron.
Let's hear him out first. Yeah.
The sun and moon are observed above the horizon every day almost every day of your life, you can observe the sun and moon above the horizon at the same time. Can you please explain what your model suggests the cause of that is?
It doesn't look like it's not shrinking. And what he's saying about the Fresnel lens is correct. There's no lens.
Hey, sorry, I haven't read the super chats yet. I think James sent $5. This thing is blocked. They have this really set up really shitty. I can't see how much it is, but thank you, James. I appreciate that. You were asking if you were permanently muted on Discord. I didn't know you were muted. I don't know why you were muted either, but I unmuted you. So sorry about that, James. Must have been some kind of thing happened one night when after show or something. Godzilla 37, $5. Kosho versus Lemonbird in a ring win. Well, I'll have to ask them that. Hold on. I'll ask them that one. Thanks, Godzilla.
Misdirection at his best. We have a fucking Fresnel lens, and you say this is an example.
I could have sworn there was one more that I saw, maybe from Esteban, but it's not in my list. So if you did send one, Esteban, and it's not in here, so I don't see it. If you did, anyway.
Sundog, it'd be
I've
three
seen a
little suns in the
sundog.
sky.
Have you seen a
There's
sundog?
a change in angular size.
Yeah, well, how often? Show me a sundog.
Doesn't matter, man. That's just
Yes,
one
it
example
does.
of how you're wrong, dude.
The
Okay.
Fresnel lens allows us to see things we can't normally see with our normal eyes, the same as if we use night vision. If we use night vision goggles and we can see stuff we can't normally see, is that still
No,
not
Fresnel
reality?
lens bends light.
So does the atmosphere.
I still wasn't given an answer.
Does light not bend in the atmosphere? Does light not
Doesn't
bend?
bend like this, my fucking god. He's got a fucking Fresnel lens, you morons. Can't you see this? You can't. You guys are drank the
Who
Kool-Aid.
cares if it's got to be a
much.
Fresnel lens?
You're
Who
drinking
cares?
the
It's a
Kool-Aid
lens.
so much that you're taking his example of using a
or a cube.
Fresnel
You can't
lens.
use anything for a stand-in. Then that's fine. We're fine with that. So we're back to needing
Fucking
first-hand
my fucking
empirical
God.
observations paid NASA shell. If we can't use a Fresnel
Fresnel
lens, then you
fucking
can't
lens.
use any of your shit.
Where's the fucking Fresnel lens in the sky?
Okay, no lens.
Where's the
Let's
sugar
move on.
water in the sky?
Where's the moon set?
Where's the 2 master's degrees, Fade NASA
Did-
show?
Did he answer? Did he answer my question?
Where's the angular size to the sun dogs? Yeah, you got 3 suns. You got 3 little angular sized suns.
You said
You
you could
don't
find
understand
the,
what's happening with sundogs. Sundogs are a bad example.
Hey, I
Rice
posted an
crystals.
image, Paid NASA show. That's the moon, and guess what's bending it? It's the atmosphere. It's bending what? It's bending the light.
You guys have drunk the Kool-Aid so much you're not calling them out on
Hold
using
on,
a fucking
Shield. My
lens.
point was, Shield.
My
My point
fucking
was,
God.
you're trying to measure the angular size to the sun and use that as evidence when it shows 3 suns sometimes. You can't use the angular size of the
In-
sun as some proof when
what?
you see 3 suns at one time. Dumbass.
Have you ever seen a sundog? I have. So what? The sun is still there. Yeah, we know. Ice crystals. We know all about it. Only happens when
The
it's really
light
fucking
bends.
cold, by the way.
Are you ignoring the fact that the light bends?
And ice crystals, yeah.
That's such
You have
a
ice
bogus
crystals in the
story.
fucking sky.
So you have
Jesus
ice crystals.
Christ.
So you have
Hey,
ice
let's get-
crystals making a perfect ring for whatever. That's the cause of the perfect ring in the sky, right?
That's correct.
Show me
Right.
the ice
Let's get
crystals. Show me the ice crystals.
crystals refracting a ring in perfect uniformity. That's amazing.
It is, yeah.
So are you saying that the ice crystals are making a lensing effect? So the ice crystals are lensing,
How
right?
often are there ice crystals? They definitely don't have a Fresnel lens. That's for fucking sure.
Just not the kind of lens you want it to be. It's the lens you want it to be, not the lens he wants it to be, just for a
Ice
demonstration.
crystal- Sundog. How often do sundogs occur? How often do he's saying that this
All
happens
the time
every
in the
fucking
north.
day.
All
No,
the time in
not-
the north.
No, not correct. It's a very rare phenomena.
Even Andrew
Not
Thomas
in the
Young,
north.
Very
even
rare
Andrew
phenomena.
Even
Not in the
Andrew
Arctic
Thomas
Circle.
Young-
It's not rare in the Arctic Circle.
Hold on a second. Even Andrew Thomas Young says that atmospheric refraction is happening.
Use a fucking Fresnel lens. My fucking god! I thought you guys could stoop no lower.
Where's that 30-second search of a moon?
I'm not gonna show you a fucking moon set. Do your own fucking Google search.
Why
you said it would take-
I thought you posted a video where you posted a picture.
I thought
it
he
would
was
take
30 seconds.
Kosho, tell him about
You guys
Andrew
let
Thomas
loose
Young
this
and the
devil.
magnification.
I'm out of here. You guys are using fucking Fresnel lens.
Oh my god.
Still shows an angular size reduction.
Sorry, everyone. Sorry, I'll only take a second. Brandon, I posted 3 links to you on Discord in your private or whatever.
Okay, so question for the guy who said angular size change. If I remove the lens and have the object move away, would there be a dramatic decrease in angular size?
Sometimes.
Yeah. The point is that the atmosphere has magnification and refraction. The refraction causes it to appear down. The magnification causes it to stay in the same apparent size.
The reason is the glare from the sun. The glare is what makes it appear bigger. It's not the magnification. It's just that the sun has a glare to it. So when you use a solar lens, you don't get that glare.
Wolfie 6020 filmed the sun with a solar filter, and it got smaller in his video as it moved away from Hawaii.
Yeah, I posted 2 videos. I posted 2 videos without a filter. By the way.
Okay, square lights
look
look round in solar
and
filters anyway, man.
I'm not. I mean, because I think what you're saying is because of the conditions of the air, what we're seeing is insignificant. But what we're seeing is exactly what you said wasn't possible to see, and now you're justifying it.
You misheard what I said. I told you.
I'm not. I don't think I was talking to you. The other guy, maybe paid NASA shill, because I'm not. I wasn't really talking to you when I popped up.
I know it's fine, but it's not an effect of the camera. I mean, it's not an effect of the eye. It's affected the camera.
Oh,
okay. Settings on the camera probably to do
like I said. Oh man, sorry.
What the hell?
Just got pulled over.
Kosher, how come like square lights, given enough distance, they look round? Every shape of lights you look at,
right,
they look round over a distance. Is that because that's their actual size, Kosher?
No, I just expressed that. I just said that the glare is what you're seeing. That's why they appear bigger and they appear to shrink.
No, but if you look at it through a solar filter, if you look at a square light over enough distance, it's going to appear round. And so is everything
what distance
else.
are you talking about? Once it's at the distance where it's
depends on the size of the light, man. It depends on the size of the light.
Distance that you only perceive it as a point source, then maybe it'll appear as a circle. But if you have,
I'm not saying the sun is square. I'm just making a point that what we see with light doesn't follow just everyday solid terrestrial objects.
Yeah.
Well, if you use a solar filter and you're looking at a square object, it'll appear to be square.
If you look at an airplane in the sky over the horizon, you know, you barely see it, and then it's still small when it comes overhead. But the light, when you at night, the light doesn't ever appear to change size as it goes across. You know, you barely a minuscule amount of change.
So
about measurable, comparable to the sun's change.
So I want to get back to Brian has found his links. I want to get back to that before because we don't have that much time left.
Wait. 2 seconds.
Okay.
2 seconds.
All
I
right.
just want to point out a contradiction. So Kosho's saying that because of the camera, we can see these type of effects. But when I talk, like for instance, I talked to a good guy. His name is Matthew Learns, and he told me that the reason that we can see a change in the apparent size of the moon when it's near the horizon, and it begins to quote unquote rise, there's an apparent change because it's an illusion of your eyes. But when you get it on camera, it doesn't happen. That seems to be the exact opposite of what you're saying, Kosho.
Yeah, it is the opposite of what I'm saying. Because if you look at the GIF that you posted, you look at what's happening in it. The sky's dimming to the point to where even before the sun is completely out of view, it's already dark. Now, this doesn't happen.
That happens a lot in less. That happens a lot in less humid regions. That happens a lot. Matter of fact, Brian, can you respond? Because you're the one. I think it's you. It might have been you that told me about the view of the sunsets when you're in humid areas versus less humid areas. But I guess we can get into what Brian presented, and if you could also not forget to pick up on this, that'd be great.
Yeah,
Has anybody ever seen the sky become dark before the sun's even set? It doesn't happen.
Yeah.
No, it doesn't get dark before the sun sets. It gets dark after the sun sets.
What do you call twilight?
Yeah, that's it. Twilight is after the sun sets. when it's still light out.
Okay. Let's move on. We can talk more about the sun tomorrow because I've got lots of shit on the sun. I think we all do. But Brian, you've got 3 links that you posted in the chat. But before we do that, let me just read a couple things. I read them on mute, but
Mic check. What's going
James
on,
is in
everyone?
here. Hey, what's up? James is in here. He said, Brandon, I'm permanently muted on the Discord. It's been 3 days now. Just wondering. James, I didn't know you were muted, so I didn't notice it.
Oh, he was talking earlier.
Yeah, I unmuted him earlier. I haven't read these forever. Godzilla 37, $5. Kosho versus Lemonbird in a ring. Win. Boxing match in the future.
It might end
Kosho
up
versus
getting.
Lemonbird.
It might end up getting.
I got 5 on Lemonbird.
We don't want to find out. What happens.
I don't think you've got
Lemonbird.
much to gain from that, Kosho, to be honest with you, because you get your ass kicked. That's not good.
I don't think it will end up in a fight. I'll say that much.
Wouldn't be a good look for you. C4, $5. How is everyone? I posted some videos in Discord of a sunset using a solar filter. In all videos, the sun clearly goes down behind that horizon.
C4, he's my biggest fan.
C4 is awesome.
Yeah, but even the solar filter shows an angular size reduction. So, what argument are they winning?
Well, let's
sure that
I mean, of course, it goes beyond the horizon. That's what things that are too far away do. Of course, it's not a geometric horizon.
I'm gonna save.
That never happens, actually.
I'm gonna save these links, and we can get back to it tomorrow. But I want to get back to Brian's thing because we were waiting for him to come back. So, one more super chat. Joshua Doyle, Kosho and Puppy Lover sitting in a tree. Thank you, Joshua Doyle, C4, Godzilla. Thanks, guys. All right.
Your audience has some of the strangest fantasies, but
I don't know
I've
what's
heard
going
some of
on
your
out there today.
fantasies, and I would beg to differ.
Oh shit. Okay. Brian, you gave me some links. Anyone you want me to open first?
No, just look. They're all links to, and they all state the same thing. That they literally state that there is a change in the sun's basic apparent motion through the sky in the southern summer, and they start stating that the sun is that the southern summer is 4 or 5 days shorter than the northern summer. That's one of their claims they make due to this.
Okay.
I'm not going to be able to talk for a few minutes. I just came in because I was listening on YouTube and heard Elijah asking me a question, so I came back in. But I know there's a delay there. But these links, they all state the same thing, that the sun is moving at a different rate through the sky in the southern summer. But you'll have to read down. There's kind of halfway or 3/4 way down each link.
Oh, gotcha. Okay, so I'm looking at the first one. It is Orbit, Earth's Extraordinary Journey. And I'm just looking for the part where it says that the sun moves faster in the southern, in the south. Now it does say, so why does this have effect on the length of winter? Well, that's down to Kepler's law. This states that a line joining a planet and the sun sweeps out equal areas during equal, yeah. Okay, that's the scientific description of the law, but what does that mean? Put simply, the law explains that when the planet is closer to the sun, it moves faster around its orbit, and when it is further away, it moves slower. So during perihelion and the northern hemisphere winter, the planet is moving faster, making the season shorter. The southern hemisphere winter is 4 days longer because it occurs at aphelion, when the planet is further away from the sun and therefore moving slower.
They say,
what?
Only some real sun moves faster, but
Haven't I been telling you guys about the equation of time over and over again?
Yeah.
Look.
Yeah, you let him have it last week, Data, for real. But
Yeah, but you got
everything that they chastise us for is actually a claim of theirs. Isn't that funny? Like
again,
you know what's funny?
You got the same implications of the equation of time wrong as did the Brian guy from earlier. Was bringing up the
What's the equation of time, Kosho? Tell me.
I told you when you asked about it last time. There's
What is it?
The discrepancy between the.
No, what's the formula?
Jesus Christ.
What's the formula, bud?
The formula is complicated. It's not even a simple formula.
It's not complicated at all.
Yes, it is. It's extremely complicated.
No, it's not.
Okay, man.
It's in the form of time.
You tell us what it is then.
So you don't know what it is. Good to know.
No, I know what it is. It's extremely complicated, though. There's no way of expressing it. It's got all these weird variables.
It's extremely complicated, is it?
Yeah, last time I saw it, it was like weird variables.
Okay, so there's two numbers involved for the equation of time.
Okay.
So how's it complicated?
Because maybe you're thinking of a different equation of time.
There's only one equation of time, dude.
Okay, go ahead and express the formula then.
So you don't know what it is. Good to know. Thank you.
Well, what is it? I don't know the one you're talking about. So let's see what the one you're talking about is.
Yeah. You can buy it in my book.
Right. So you don't know what you're talking about then.
I schooled Rumpus. Right. I schooled Rumpus a couple of days ago.
I was there when you were doing this with Rumpus, and you didn't go over the equation.
You didn't school me at all. I knew all
you didn't even know. Yeah, you
I
did.
Didn't happen to know the equation of time is the name. I understand the maths that cause it.
What's the equation of time then? Tell me the formula.
You claim that the Earth changes its rotational speed, which is completely wrong.
No,
so you go ahead and print your book because you're spouting complete
drivel.
drivel.
It's the sun that changes the speed, not the Earth rotation. Sun.
You said that the Earth changed its rotational speed.
Not at all.
You did. What?
Nope. It's the sun that changes and speeds up and slows down.
You
It's not the
claimed
Earth.
that if you had a rotating thing on the end of a stick, and if you moved the stick, it would change the speed with which the thing was rotating. That was the entire argument. We were talking about the rotation of the Earth, and you claimed that the Earth changed its rotational speed, and I kept on telling you it was just the orbital speed that was changing. But you didn't seem to understand that.
The Earth isn't moving, rotating, changing nothing. It's the sun that's moving. That's what the equation of time shows. It's the sun that moves, not rotation of the Earth.
Now, the equation of time does not say anything of the sort the sun moves. You've just made that up.
Give me a
citation for the equation of time in which it says the sun is moving and we're stationary, because you won't find it.
What do you measure against clock time? The movement of the sun or Earth rotation?
So the clock time is so you're trying to talk about what they call the solar time, I think, is the mean solar time. Is that what not the mean solar? The mean solar time is the same as the clock time, and then there's
solar mean time is clock time, and then we measure against that. The equation is the movement of the sun minus solar mean time to get the variance. That's all the equation of time is.
That is correct. Yeah. Yes, but what Kosho was asking you for...
Kosho didn't know. I know. You didn't know. It's all good.
What Kosho was asking you for was an explanation. We know that you can just subtract two numbers together. That's very easy. But what Kosho was talking about was how you derive that. And that's the thing that you don't understand or have a clue about.
Tell me, Rumpus. Go ahead.
Right, well, it's rather complicated, as Kosho said, because you have to take...
Tell me.
Well, you won't understand it because you don't understand any maths at all.
Uh-huh.
There's a first part in the chat.
I mean, for instance, do you understand how an ellipse works? Do you understand the focus of an ellipse?
Yeah, now he's going to give you a math quiz.
Just tell him, Rumpus. Tell him instead of focusing on
in the background. He asked me to explain it in terms of maths. So
Rumpus, I was there.
So it was moaning in the background who can barely be heard that I'm going to give him a load of maths. Yes, he asked for it.
Rumpus, I was there that night. You did not even. Rumpus, I was there that night. You did not even know what he was talking about, or that the equation of time even existed. So
I knew all about
I remember that too. There's no equation of time. There's no such thing as an equation of time.
He's talking about the nomenclature, man. But he knows
the type of it. But I knew all about the effects, and I know the maths behind it. I just didn't happen to know it was called the equation of time. That was all.
You don't know how to wipe your ass.
You do need it, Jeremy. Obviously, like everything, Jeremy, you misremembered that time. Also, when I got annoyed with you, it was discussion about refraction. You said it was about something else. You've got the memory of a goldfish. And clearly the same thing is true of flat Earth data.
I don't trust that you know what you're talking about. You're blowing all this air. You're blowing all this air. Why don't you just move the conversation forward?
He specifically said that the Earth changed its rotational
instead of gossiping like a little girl.
You're an idiot.
You're
You're not worth talking
gossiping
to.
about.
He's right.
You're
You're just an
gossiping
idiot.
about what
So the
happened.
point
I'm
is, the
asking
fun
you.
data
I'm asking you
doesn't
to educate the
understand. If you
audience
overtalk me, I'm
and
going to ignore
prove
you.
to the
If you
audience
keep on
that
overtalking me,
you
I'm
know
going to
what
ignore
you're
you.
talking
Alright.
So
about,
flat
and
Earth
data
Day, open
doesn't.
the
Damn,
conversation
Rumpus,
flat
can you
Earth
be
Day
an
tonight.
adult
You
for
can interrupt
once,
me.
bro?
You get if you can
Can
wait
you
your
be
He's
an
turn
just
to
going
adult
to
talk.
for once?
overtalk you, Eli. That's all he does.
Stop being a little bitch.
Well, I don't care that he's over talking me. I'm sure the audience hears me saying, "Can you stop crying and
Dude, there
just
isn't
do
one
what you
time he
came
said
here
he
to,
control
and
himself.
just do what you came here to do?" You're saying Daddy doesn't know what he's talking about. You're saying you know what he's talking about. So start talking about it. All you're doing is talking about how people don't know this and people don't. Just talk about it.
Oh, I muted him again. He's just totally derailing things because he doesn't know how to have a conversation.
Hey,
He's
Brandon.
unbearable. He's unbearable, isn't he? Like
Yeah,
you
Brandon.
try to
Brandon,
listen to him, but
I
he's an
didn't hear. I didn't hear that. Like, how did he switch that there? Like, what I heard with the exchange between Data and Closure, unless I took a nap in the last 5 minutes, all I heard was Data asking him for the equation of time.
Yeah, and then he
And
accused
him
him of not knowing
saying,
math, not understanding mathematics,
that's,
and then he went on to
Right, right.
Jeremy,
So,
and then he changed the subject 5
Brendan
other
and
times.
Elijah, if you look in the chat, I posted right there and right there. This is the derivation for exactly how you'd make that calculation. Of course, the difference between the two.
Kosho, question for you.
This is actually what you. This is actually what equation of time.
Kosho, how can you, if I was to look at the ground, could I calculate solar mean time versus the apparent solar time looking at the ground, or do I have to look at the sun to do it?
Well, you want to see how fast the sun's coming back and ending up in the same.
So it's not Earth rotation then.
That would be the apparent solar day.
So it's not Earth rotation then.
Would be the 24 hours that you.
So it's not Earth rotation then, right?
No, that's caused by the rotation.
Jeremy.
Oh, okay.
The discrepancy between those two values is caused by the difference in the orbit, though. But the fact that it's the speed at which it's traveling, the fact that it's going around once a day is from the rotation.
The rotation that was never proven.
It
We can't
actually
detect or can't see or
derives.
can't observe, can't feel. That
It
rotation.
solid one, two, Data. Got to give you credit here. Solid
This
one,
is
two.
what is meant by
Begging the question.
This is what I meant by a very complicated equation. So
What's the equation? Give it to me. I got a pen, Kosho. What's the equation?
I posted it in the chat, man.
Okay, so hold on. The equation is, how do you calculate the equation? What do you have to observe?
Posted it in the chat, man. I've already told you.
I'm asking you.
I've already told you the two things.
To make the calculation work, what do you have to observe?
Well,
There's only two things you have to observe, Kosho. There's only two things you have to observe to calculate. What are they?
The discrepancy.
There's only two things.
The thing that you're talking about, the thing that Kepler and all that. This is the actual equation.
Yeah. What do you have to observe to use the calculation? There's only two things you have to observe. What are they?
Well, you're gonna have to know what the tilt of the Earth is. So it's not just two things, man.
Nope. You don't need to know that at all. You don't need to know the tilt at all.
Between the two.
You don't need the tilt. You don't need any of that. There's only two things you need in the equation of time. There's only two functions in the equation of time.
You're talking about the two values, the mean solar time.
The calculation is this. This is the formula. This is the formula. Apparent solar time minus solar mean time. That is actually literally the equation of time.
That gives you the
again. Yeah, exactly. Exactly.
That doesn't.
So hold on. What do you have to observe? What do you have to observe to do the calculation? Tell me.
I've just told you right before you said it. I said the only thing you need to observe is those two things. That gives you the discrepancy between the two.
What are those two things?
What are they? The mean time, the apparent solar time, and the solar mean time.
So not Earth rotation.
That's both of those are caused by Earth rotation.
Oh, so it's inference. Your inference is saying that it's caused by it, but the observation calculation is based on the movement of the sun. Movement of the sun against clock time.
This is good. This is good shit, Data. Good work, man.
Yeah, nice job, Data.
What did Flat Earth Data do just now?
He exposed you because he's
So
asking you how to calculate something. First, you said it was too complicated. It's really complicated, and it sounds like about the simplest equation there is. And then when he asked you what you need to calculate it, You started talking about Earth rotation and not the actual values, the actual observed values.
I said literally those words.
The phenomena that you need to observe in order to calculate it. It has nothing to do with
solar
Earth
time
rotation.
and solar mean time.
Either one. Neither one has anything to do with Earth rotation. You're observing the sun. That's all you're doing.
Yeah. So if you actually look at Kepler's work on the equation of time, you look at the actual equation.
Kepler just observed the
So
sun.
hold on,
Yeah, so
hold on, Kosar. Another question for you. Then talking about question. Does Kepler? Hold on. Does Kepler have? Hold on. Does Kepler have? Does Kepler have the sun? Hold on. Does Kepler have? Hold on. Does Kepler have the sun on the equatorial plane, or does it have the sun on the elliptical plane?
Right.
When he's hold on.
No, I'm not answering your question, Flutter. Yeah. You're acting like a child. I'm in the middle of saying something, so you just wait till I'm finished. But yeah, so if you look at Kepler's calculation, the actual equation is to get those numbers, to get those values, involves the equations I posted. What you're left with to get the discrepancy is going to be 1 time minus the other time. To actually get those times, you have to calculate the fucking.
Okay, so hold on.
You don't.
What does Kepler do? What does Kepler do? Does he put the Earth on the ecliptic path, or does he put the sun on the ecliptic path to do the calculation?
He would probably put the sun on the ecliptic path.
So, like we observe it in reality, then.
Yeah.
Thank you very much. So, no supposition of Earth rotation; it's back calculated for Earth rotation after the observed phenomenon of the sun moving first.
No. That's just how you see it, so that's how you would do it. The sun is on the ecliptic in the sky.
Yeah, exactly. That was my point, Kosho. That's how you see it. That's the phenomena you're looking at, and then you're calculating based on the phenomena. Kepler never saw Earth rotation. He never saw anything like that.
Okay.
In fact, what Kepler did is base all of the celestial orbits off the observation of Mars. That's what he did.
Okay.
None of us have seen Earth rotation.
Yeah, you just claiming that people don't know the Earth's rotating.
Yeah.
He knew the Earth was rotating. He was an astronomer.
That was part of his model.
Yeah, exactly.
He was a mathematician first off.
Okay, you can be a mathematician and an astronomer.
He was looking at lights in the sky to determine the shape of the ground.
Kepler was an astrologer. And
you can be an astrologer, an astronomer, and a mathematician.
Hang on. Kepler took the geocentric sun cycle that he got from astrology. He possibly got it through Brahe, because Brahe was also a master astrologer.
He killed Brahe, man, with Mercury. He killed him with Mercury.
Right.
Well, yeah, but he got his. The point I'm making is he got his sun cycle, the geocentric sun cycle, from astrology, and he then amalgamated it to the Copernican model. He just exactly. I've been saying it for myself for years. He just back engineered the whole lot. He never saw any Earth rotation. No one ever saw Earth rotation.
Exactly.
Rumpus, Kosho never saw any Earth rotation, except for a NASA video. Do you know what I mean? We don't see any of that. We see the sun.
Why don't you not try to assume things I've done, dude? I've done.
Did you see Earth rotation?
I've witnessed.
Did you see Earth rotation?
Actual Foucault's pendulums.
Well, okay. Did you see Earth rotation?
Yeah, I witnessed the consequences of it. Yeah, directly.
What did you witness?
I witnessed it every day.
What did you witness?
I witnessed the pendulum I made process at the exact degree that
you witnessed the Earth moving underneath the pendulum, is what you're saying.
I witnessed the pendulum process.
Did you witness the Earth moving underneath the pendulum?
Latitude it was at.
Did you witness the Earth moving underneath the pendulum? It's as simple yes or no.
That was what caused it to happen. I witnessed the Earth.
So you did witness it. So you
can't say yes or no, can you?
Because he's asking a stupid question.
No, it's not a stupid question. He's trying to make a point.
What I witnessed was the consequences of the Earth rotating.
You know what's crazy? But his answer to Brian is the same judo he was given data just a minute or two ago. It's literally the same.
I didn't give Flair data any judo. I posted the equation. What do you think those equations came from?
Look. All I'm saying is this: if you think that the story of heliocentrism is going to hold up against this kind of dissonance and scrutiny, you're mistaken. You got to get a better trick, bro. And I'm not just talking about you. I'm talking about all of your cohorts. This is getting bad.
Elijah, when you actually do an experiment and then open your eyes, maybe you'll understand how the world works. When I'm describing an experiment that I did and somebody's asking me a stupid question, I'm going to correct the question by saying what I did observe.
Kosho, you said experiment. Kosho, you said experiment. Can you run me through it? Kosho, you said it.
Yeah.
Kosho, you said experiment. Can you run it through me? I want to do the same experiment you did. What's your phenomenon you observed?
I'll just give you some videos you can look at. I don't feel like explaining anything.
So you don't want to tell me, right? Yeah, I want to do exactly what you did.
Tell us about your experiment.
It was a secret experiment.
Don't scientific papers like they're not Pictionaries, right? They all they have are the actual information. So we're asking you for information, not videos to go watch. You did an
I actually
experiment.
wrote a paper.
You did an experiment. Show you did if you did an experiment, show your work, bro.
Yeah, how many times have you read the paper that I've sent you that I wrote from the experiment that I did? 0 times. All of you guys.
Hey, Kosho, what was the phenomenon you observed in your experiment?
You can tell me I have a paper where I sent you all papers. I can probably go in my DMs. I probably see the paper I sent.
All right, so what kind of experiment do you have to do to find out when solar noon is? Go ahead, let me know what experiment.
What kind of question is that?
Natural phenomenon is there, please.
What kind of question is that?
We gotta have
And how is it relevant to this conversation, man? Why are you asking about an experiment for this the solar mean time?
Oh, well, you're saying that Kepler used the tilt to get those equations.
Yeah, and his calculations.
But hold on, let me finish. But to know when solar noon is, hence the term solar noon, right?
Solar noon has nothing to do with this, man. You don't know what you're talking about right now.
You don't need to know anything about the Earth to know
we're not
when
talking about
solar noon is.
But all you're doing is begging the question, and here's how.
Yep.
Oh, Elijah, you're really low now.
Sorry.
I can't hear.
Can you hear me? Can you hear me now?
Yeah.
Yeah, we can hear you.
Okay, you're begging the question. Here's how. You're saying that the reason for the reason for what data is talking about is due to Earth curve.
I didn't say that once.
Yes, you did.
No,
Yes, you did.
he asked me what causes the solar time.
Exactly.
The tilt.
That's what I said. That's what I just. Okay, fine. That's begging the question.
Okay, so that's two different things. Right. And he asked me a specific question.
It's not two different things. It's the same exact thing.
He asked me a question. He asked me what's the cause of that, and I told him what the cause of it was. So I'm begging the question.
So, Kosho, you observe the sun moving in the sky, and you somehow formulate that that's the Earth moving. And how did you do that?
Well, one way is by doing the test that Foucault did with the Foucault's pendulum. Another way, all the other observations that show you that the
so you witnessed the Earth moving underneath the pendulum, then. So you witnessed the Earth moving underneath the pendulum.
I didn't hear your question.
So did you witness the Earth moving underneath the pendulum?
Did you hear last time you asked that? What I said to you?
Yeah, I know.
I witnessed the consequences of the Earth's rotation.
You weren't very clear on the last one.
You didn't say yes or no.
I witnessed
it's a yes or no. It's a yes or no answer.
Okay, that's what I witnessed.
So did you witness the Earth moving underneath the pendulum?
I witnessed the consequence of the Earth.
Because you knew that that's the original thing.
It's a stupid question, man.
That's the original thing. Foucault himself.
Yeah.
Brian, isn't that where he's begging the question? He's saying it's a consequence of the Earth's rotation. That is you begging the question.
Exactly.
He's 24/7 begging the question.
He's saying, look at this pendulum. It's moving because of Earth rotation. It proves that the Earth's rotating.
No, well, the idea would be, the hypothesis would be that if the Earth is rotating, then it's going to be, you can swing a pendulum back and forth, and it would precess at different rates depending on how far from the North Pole you were. The North Pole should rotate once in 24 hours. Anywhere south of that, in between there and the equator, should precess at some rate equal to, cosine. You take the cosine of the rate it's
doing. Is this still in the hypothesis?
Yeah, this is a hypothesis. And so when you do the
hypothesis of control pendulum,
when you do the test, you just simply swing the pendulum, and you see if it behaves the way in which you predicted.
Oh, wow!
When we do the test,
why do you have to swing the pendulum?
You can tell that the reason why it precessed was because the Earth.
Hold on, guys, I got this.
Why do you have to swing the
So-
pendulum, Kosho?
Hold on. I'm trying to, I would try to. Hold on.
Kosho varied and manipulated the turn of the Earth, apparently.
Yeah, I was gonna ask, what's your independent variable when you do the test?
The independent variable would be the pendulum swinging, and you swing it
Is the
directly.
cause-
You swing it directly back and forth.
So
And
the
the
pendulum causes
pendulum
the Earth to
precession.
turn?
Wow.
We're trying
you
to
have
find
to
the
start
cause
the
of
pendulum
percent-
swinging.
Guys, I got this. Guys,
Hold on,
I
let
promise.
Jeremy go through with this.
Okay.
Yeah, Jeremy got it.
So, the pendulum swinging is the cause of the pendulum deviation, and not Earth
No.
rotation.
No, you asked what the independent variable was, right?
Yeah.
Right. The
We're looking
independent
for the
variable.
cause of why.
Right.
We're looking for the cause of
The
why
independent
this pendulum is
variable.
deviating, right?
The independent variable is going to be your latitude and the pendulum swinging.
So the latitude is causing the pendulum. We're
No,
looking for the
latitude.
we're
The
looking for
latitude you can change.
We're looking for why this pendulum's precessing, right? Or
Yeah,
is that
because
not
the Earth, that's in the That was in the hypothesis, man.
Yeah.
Did you hear the hypothesis?
how are we gonna
Yeah, but-
how are we gonna prove that that's what's,
Jeremy,
that's what's
By
happening?
swinging
Jeremy,
the pendulum and
he
seeing how.
already
Hold on,
gave
Brian.
you the cause.
He knows,
No,
Brian.
but
He got it. He got
Jeremy's
it.
missing something.
He got it. He got
He
it.
already gave the cause. He started
Yeah,
it
the
swinging.
latitude, we know.
No, he has
The
to
He doesn't
start
have a
swinging.
vibe. He doesn't
the
have a
That's the
latitude
point.
is that you can
independent
adjust.
variable.
You can adjust
I
the
know. We won't
latitude.
dra-
If we were on,
Watch it
Jeremy,
process at different rates.
Jeremy, if we were on a rotating, moving surface, would that pendulum not be swinging on its own? Why doesn't he have to start it swinging?
No, it would not be swinging on its own.
You were in a
Why
closed
not?
system.
If we're on a
That's
rotating
not how, that
surface,
doesn't, that's not how
why
things
does it
work.
not move? Can you put a
It would
pendulum
deviate
on any
from the
moving
center
surface
point.
and expect it to stay
doesn't
still?
cause it doesn't cause the pendulum to swing. It processes
Why
the
not?
swing. That's all
Well,
it
that's
does.
because it's not rotating. There's no movement
No,
of
it
the Earth.
doesn't. It doesn't. You're confused.
Well, if it was, if the Earth was moving, then the pendulum would move by its own accord. It wouldn't need you
No,
to
it
do
wouldn't.
it.
It wouldn't. You're confused.
Why not?
Hold on.
Sure,
So let me ask.
Okay.
Kosho,
Let me
with
ask
this
this.
experiment that you're describing, it sounds like your cause was the latitude. Changing the
No,
latitude
no.
causes the pendulum to
No.
process. Is that right?
The cause is not the latitude. The cause is the Earth rotating.
Yeah, but you didn't. You
can adjust
didn't
it.
vary the. You didn't vary the Earth rotation. You just
Yeah,
changed
you
your
can
latitude,
adjust
right? And then you
latitude.
added on this
Right.
story about the reason that it changes based on latitude is because of Earth rotation.
That
That's
was
all
in the
you did.
hypothesis. That was in the
Answering the
hypothesis.
question.
That was the hypothesis. If you don't remember, I told you the hypothesis.
I don't care if it was in the hypothesis.
Should process depending on how far
In
you
your
are.
hypothesis,
I
Yeah,
said.
but where's
let me
the
ask
part?
this real quick.
Hold on.
In
Where's
your
the part where you
hypothesis,
where's the part where you showed that the Earth rotation is causing the pendulum deviation?
By the
I
equation.
missed that part.
Yeah, by the equation by which it processes.
The equation.
That
Yeah.
doesn't.
Hold on.
No.
You use the angle away from the wherever you are on the sphere, the angle you are between the North Pole and the equator. You use that angle to predict how much it's going to process, and then once you start swinging it, it's supposed to process that much from that latitude. If you want to adjust it, just go to a different latitude.
Would
What's
that
the
go
IV
into
again?
Where's the part
Gleason,
where we-
Matt?
How would this
What's
happen
the
on a flat
IV?
Earth, guys?
Where
What is the
How would it
IV
happen on a
again?
flat Earth? Someone tell me how the
Hey,
Foucault
someone,
pendulum works on a
not
flat
the
Earth.
shit.
You don't want to
Not the
know.
shit.
You can't handle
me-
how it would happen
not
on
the
a
shit.
flat Earth show. You can't handle it.
Not the shit. Not the shit. Can you?
let me
can
ask
you
a
show us
question
any-
on this, please,
Hang on.
guys. Can
Not
I
the
ask
shit.
this?
Nasa.
In your-
Can you
in
show
your
me any
hypothesis.
physical demonstration, please?
Hey guys,
Not the
let
shit. Can
Hold
you
on.
show?
let Jeremy finish with
Not-
his questioning, please, and then we'll move on. Jeremy, are you done?
Yeah, where's the part where you show that Earth rotation is causing the pendulum deviation? Because I'm missing that part.
Yeah, that's in the prediction. In your hypothesis. In your hypothesis. Well, if you want me to, if you're gonna ask a question, you're gonna have to let me give you the answer. Okay.
Yeah,
But
That
if
was my fault. That was my fault.
Yeah, if the hypothesis is if the Earth's rotating, then as you move at different latitudes, it should process at different rates depending on the latitude. You then use the dimensions of the sphere you think you're on to predict what it's going to be. You then watch the precession, and you see if it matches your predictions. See if it changes at the rates in which you're predicting. If it does, then your prediction, then you have a sound prediction. You have a
If
sound
the
test.
Earth is rotating, is begging the question.
The better question is, Jeremy, how would you falsify it, Jeremy? How else could we?
Guys, Jeremy's got this. He really does.
You can try to falsify it, but until you falsify it, you say that this hypothesis stands a test.
It doesn't stand. It's not even a viable hypothesis.
Then
You don't have an
falsify
independent-
it.
You don't have
Falsify.
Don, you don't have an independent variable
I
that's
just
showing
can't-
us that the Earth rotation. Listen, you don't have an independent variable showing us that the Earth rotation is indeed the cause of the pendulum deviation. You're missing that part.
Yeah, the independent variable is the latitude. It's going to change.
The latitude can't be.
You can adjust the latitude and get different results.
I'm sorry to interrupt, Jeremy, but I just want to say one thing. I just want to say one thing real quick. Doesn't the observed natural phenomena have to be the Earth rotating?
Yeah, you can say the observed phenomena could be the sky moving, the sky appearing to rotate. And you can,
not the
the
Earth,
question could be like, is the sky rotating or is the Earth rotating? And then you
Yes,
go,
let him beg the question that Earth.
Bro, the gyroscope falsifies that it's staying still. You see what I'm saying? And he has a correlation per latitude. Now, if you want to falsify the standing of that, don't over position it like they're proving it and they're he's just saying that's a strong inference, bro. Don't disrespect it. Y'all gotta respect
No,
it.
he's saying that proves Earth rotation.
Don,
The guy that just talked there, the guy who just talked there, can I talk in for a moment?
No,
the man
see,
who just
Don,
talked there.
Is the cause latitude or Earth rotation?
Sorry.
The cause
Well,
would be
he-
Earth rotation.
Portia's at the state that
Then how did you manipulate Earth rotation for it to be a valid?
Because you have
IV?
to understand what an
Portia
independent
stated
variable
there
and
were
an
two
independent
independent
variable are.
variables.
The
Portia
cause
stated
of
that the
independent
pendulum
variable just
and
has to be
also the latitude were both independent variables. That's two different variables. For
cause
start.
the whole thing.
You don't understand.
Now, could someone please show me a free hanging pendulum on a moving surface that isn't moving, where the pendulum doesn't move? Can you show me a video of a free moving pendulum on a moving surface where the pendulum is still?
They falsify the still Earth.
Let's get into reality.
They're not
pendulum
proving
is
things.
attached to the Earth.
I don't give a damn. The claim is that the Earth
I don't know.
rotates
Put it
underneath
in
the
the
pendulum.
truck then. I don't know.
Right? That means the pendulum would be moving if the Earth was moving, but the pendulum stays still. And if the Earth is moving underneath the pendulum, then it's also moving underneath airplanes, drones, helicopters, hot air balloons, gliders, etc.
I could agree with some of
Do we see that? No.
Conservation of
Brian, does
angular
a pendulum
momentum.
start to swing if it's on a train? No, it doesn't, and that's the
No,
same
so
reason.
come on.
on a train,
And that's the
Rumpus,
same
we are not on a
reason.
train.
Can
We're
I
not on a
finish my
train.
sentence?
It
Can
would
I
be
finish
swinging
my
on a train.
sentence?
Yes, Rumpus.
And
No,
the same
no,
reason
a
that
train is
a
parallel.
Jesus
A
Christ,
train is
can I finish
parallel.
the sentence? Can I finish the
Unfortunately,
sentence?
would happen.
Can I
No.
finish the
Trains have movement.
goddamn sentence?
Not
No.
interested, Rumpus.
We're not on
Yeah,
a
the
train.
pendulum
The train
does
is
move when the
parallel. You
train
would have a
takes a turn.
circumference difference on anything hanging that might give you some extra momentum to make something happen. If y'all actually want to explore this with intelligence and not hate, and Brian has an interesting point. How much force do we need? Could we show this? You know what I'm saying?
Any
Right.
acceleration is going to cause the thing to swing, right? But we're talking about constant.
No, but it's not constant.
Yeah, it is.
It's not constant.
Yeah,
You have same degrees per hour, but you have different linear velocities.
Yeah,
on
but
the
you're,
top
yeah,
of the pendulum and
but
the bottom of the
the effect of that is a centrifugal force acting outward. Outward is not the direction that the pendulum is hanging. It'll be a little bit lighter, but it's not going to be swinging.
Yeah, but it should be
Can I throw a
hanging
monkey
out. It
wrench
should
in
be
here?
moving upward.
Can I
Sorry,
throw a
Eli,
monkey
sorry.
wrench into this? No, it's okay. Because I just want to say something that's like related, but I guess we want to play with our food. Like, you know, if this was a day where I didn't know better, you know, I'd have to think about this long and hard. But in order for for me to be, oh, maybe it's rotating. Maybe this is showing me what Kosho's saying it's showing me. Maybe that is a valid experiment. Like, but that would all be predicated on an Earth that has curvature.
Oh my God! All right. Well,
Yeah,
look,
we'd have to have a symmetrical horizon for the sun to come up and go down behind. We
Look,
don't have that. It's over.
Coach, so the centrifugal could be there, right? But we're thinking of balance, right? Maybe equator position. If you're changing latitudes, you have this slightly non-symmetrical thing going on there. And maybe you could start to see a little bit of the stillness processing into some sort of little bit of a pendulum.
If you're moving up and down the latitudes, what are you talking about?
Yeah. Like think about your centrifugal force, the vector on that, right? And then think about how it's going to balance on the equator position of a rotating sphere. But then think about how that force will slightly not balance as you now have like an angle as you move off the equator. And that rotation is going at that. It's not a parallel position anymore like the equator was.
Yeah, the only thing is when you're in a object, if you're in a train car, for example, going north and south, and it's hanging from a pendulum, it's going to be dictated by the rope that it's hanging from and the thing it's attached to. And the thing it's attached to is the train itself or whatever, which whatever Coriolis is going to expect to feel, it's not going to be, it's not going to cause the ball to be independent from that. That's hanging from.
That's not Coriolis.
No,
That's not Coriolis. Coriolis
no,
is
conservation.
It would be Coriolis if you're talking about north and south and the.
Okay.
No, that's a load of rubbish. Coriolis is a visual effect that we would observe if we were on a rotating sphere. We'd see planes are moving in a linear fashion above our heads to appear to deviate. We don't see that.
This is a visual
That's Coriolis.
See that? No.
And now we're talking about how if something was so tall, right, the circumference difference of it rotating around with the Earth, right, pendulum was so tall that maybe as one position has to conserve momentum through the system. You know, I'm not good enough to follow all this, but we do know that there's a difference. So balance that out. So think about it sincerely. Thank you.
I'm trying to think about it, but somebody talked over you.
Hey, Kosho, do you have to have a certain length of string and a certain weight?
Yeah, the longer the better, and the heavier the better. Yeah.
So would it change oscillation based on the length of the string?
No.
The rate of oscillation? I'm sorry?
You said would it change the oscillation? Like change the it would change the period. Yeah.
So it changes the rate of oscillation, right?
It would change the
So
rate.
if I had a 2-inch string with a weight on it and then a 5-inch string, the oscillation would be different, right?
It would change the rate at which it's swinging back and forth, of course.
Yeah, of course. Yeah. Do you add that in?
No, that has nothing to do with it at all.
Has no variable in the scientific method?
The Earth's rotation is not changing the rate at which it's swinging.
So I could just slap whatever together. I could slap whatever string together, whatever weight I can together, and I just look at the oscillation. I hang it from my finger, and I look at the oscillation back and forth.
The longer the string and the heavier the weight, the better.
Okay, sure. But if I don't have a really long string, I think you told me you hung it from a 2-story building, right?
The roof, the ceiling of a 2-story building. That's right.
Yeah. So you put it from a 2-story building, and what did you do? Did you have somebody from a 2 stories away pick it up and drop it, or would you just?
No, I tied it to a chair, and then I burnt the string.
Right. And so where's the science in that?
The prediction and then the measurement.
So the prediction is the science. The prediction is the science. What's the prediction?
I already went over this, man. If you want to wait a little bit, then just rewind it back.
Yeah, we already went over this. It's not a valid hypothesis.
What's the
Why isn't it valid,
Jeremy? What's the supposition for the prediction?
Just go back and rewind the tape, man. But Jeremy, why do you say it's not valid?
Prediction.
You don't have.
Just go back and rewind it, man.
Yeah. You don't have a valid experiment, brother. Sorry.
I already went over it, dude.
What's happening here?
Experiment.
Yeah, but Jeremy, tell me why you say that though.
What's happening here?
So Jeremy, tell me why you say that.
Hang on. What's happening here?
Jeremy.
This is a begging the question holiday. That's what's going on here now.
All right, Jeremy.
My original question was never answered.
Jeremy, could you tell me why you said that?
My original question was never answered, even though I asked it.
No one's listening to you. I'm trying to ask Jeremy what his original.
I'm listening. He said the funniest shit I heard all night. He said it was a begging the question holiday. I thought it was hilarious.
Yeah. Okay, Jeremy. What was the
Exactly.
Jeremy, what was the issue, Jeremy? When he's done, Jeremy, tell me what the issue
rotating underneath the pendulum. That's the 4th time I've
You
asked
already
that
know
question.
Jeremy's issue, dude. Quit asking him. You already know it's.
Don't have a viable.
hypothesis.
You don't have a viable independent variable that's going to show us the cause of the pendulum deviation.
Right. So Jeremy,
It's not claiming that the Earth is rotating underneath.
Jeremy, it's hard to respond to you. I'm going to wait for this guy to stop running his mouth, and then I'll be able to respond to you.
Well, no, you didn't never answer my question, Kosho. I asked you, are you claiming that the Earth is rotating underneath the pendulum? And you have yet to answer that question.
I told you that was never my claim. I told you the claim is that the consequences of what I saw were the Earth rotating. That's what I told you. You asked me if the Earth is rotating beneath it. No one told you that this was what they saw.
Prove anything then.
So there's no point in
asking. Pendulum swinging around the place. There's no proof of anything. You're supposed to be proving Earth rotation. That's not a
How
proof.
does he
I want to
answer?
know.
How does he
I
answer
want to
if he
know what
don't
the
shut up?
hypothesis. Let me say this
These
real
guys
quick.
don't shut up, man.
I
It's
want
like
to
I'm trying to
know.
respond to something Jeremy just said, but just
Just
take forever.
how it
People
is
talk.
the QE fan club here. You don't have a proper experiment. Of course, they have no idea what experiments are because they all stopped their
Sorry,
scientific
QE didn't make
education
the
in high
scientific
school.
method. Hello, hello.
Yeah, I know,
QE
but
didn't
the
make the
cause,
scientific method.
the independent variable is not the cause of the observation. It's the cause of the dependent variable. So whatever is causing the dependent variable to differ from other experiments is going to be the independent variable. That's what's meant by the cause and effect relationship.
So how do you negate your effects of controlling the pendulum? Because obviously you can't have a pendulum swing for 1 hour, let alone 24, if you're controlling it with gears or electronics.
I didn't swing it for 24 hours.
Can I see
Yeah.
Can I see how they negate? Where they negate?
I didn't swing it for 24 hours. I swung it for 20 minutes.
Yeah, you can't. But they say that their pendulum that shows, in the museums spins for 24 hours.
Right. So that's not me. That's the ones that are in the museum.
Yeah, I'm just saying
So
that no
if there's no,
pendulum
so
does
your
that.
question you're
Those are
asking doesn't apply
the
to
museums are the ones that give backing to the.
They get the
moving
same rate
Earth.
I get. That's right. Based on their
It's
latitude.
amazing how it is. They got a very
You
sophisticated.
can't even
device.
have a pendulum swing for an hour to get any.
They're great lawyers like them.
Yeah, you can swing a pendulum for 1 minute, and you can get some
He
rate.
did a 20-minute experiment, guys, and determined he was right.
How do you negate the fact that you might have introduced the pendulum swinging in that trajectory?
Okay, that's a good question. That's a great question. That's a great question. That's a great question. Simple answer is I did it multiple times. Got the same rate. Simple answer to the question that was asked was I did it multiple times. Simple answer to the question that was asked to me just now when the guy finished talking was that was I did it multiple times. James, guy, I don't know why you always think it's your time to talk.
Guys, I'm gonna cut in here.
Somebody just asked me a question.
I think we're good. We're good for this. Well, you guys can continue.
I'll tell you after the show, James.
Yeah. Hold on. I'm gonna read these super chats and then we'll call it a night. We're already half an hour over. Joshua Doyle says Rob Skiba for the win. Thank you, Joshua Doyle. Must have been referring to the Fresnel lens. Appreciate that, man. C4. Don has taken Jeremy's place as worst glober. Damn. Shots fired. And then C4 follow up. Damn, trying to insult Jeremy totally backfired. Care to comment, Don or Jeremy? No? Okay. Thank you, C4. Appreciate it. All right. I appreciate the panel's time tonight. Some good discussion. And we'll pick it up tomorrow night. We'll discuss the sun and whatever else comes up. But I've got some stuff, some videos from C4 that I was playing on here, and everybody bring their sun stuff. We can talk about sunsets and all that shit. Go over the videos that show the sun clearly moving across the sky, and we can talk about what we see, what we observe. All right.
I got something to tell you later, Brandon, tomorrow regarding early astronomy, and an interesting little calculation that. Anyway, I'll tell you tomorrow.
Okay, sounds good. All right, thanks, guys. I'll be back.
Hey, Dad.
Okay, thanks everybody. Went overtime tonight. Why not? It was a holiday weekend. We will see you tomorrow night, same time, same place. Thanks everybody. Thanks to everybody who supported the show with super chats. Shout out to the mods and everybody in chat. Very active night. Appreciate it. And we will see you tomorrow night. By the way, pendulums don't prove shit. See you later.